morning, everyone. My name is Sebastian Tramp. I'm the CTO of the eccenca GmbH, and I have the honor and the pleasure to welcome you to the 13th Semantic Web Day in Leipzig, the Leipzig Semantic Web Tag. Before I start to give you an overview of the program today, I was asked to give you 3 important notes. So in case of an accident, you have to go to the straight and then to the big staircase. There's also the toilet. This is the second note. And you are not allowed to bring coffee to this room because the chairs have a white polster and they don't want to waste it. Okay. In addition to that, I want to thank my partners in organization, especially Nieves, because she did the most of the organizational work. So this is this year we organized this event with 5 different organizations, the LSWT, DBpedia and Infi, eccenca and TU Chemnitz, where Professor Martin is now compared to last year. We have prepared a super interesting program for you, which contains of 2 keynotes, which will be held after this welcome session. We have, in addition to that, 4 sessions with 15 talks, all in all 22 speakers and 26 student posters. And regarding the student poster, I want to add some special notes. You have on the back side of your badge, you have 2 different dots. And today we have 3 breaks, 2 coffee breaks, 1 lunch break, where you can go to the posters, right in the direction of the emergency exit. You have all the poster stands, and these posters are from students from 4 different universities and 4 different federal states in Germany, and they brought their posters which were part of their exams or their studies. And it's super interesting because they are the next generation and you can get in touch with them and talk to them. And at the end, I would like to ask you to take these dots and put the green dot on the poster where you think the content is the best, and the red dot where you think the poster was best designed. And at the end of this day, we present 2 prizes to them, and we just count the dots. Okay. We will start right after this session, or this welcome session, with 2 keynotes. I will talk about these keynotes at the end of the welcome session. These keynotes are held after one after the other, so there's no break between these keynotes. Both keynotes are held by 2 persons. On the website, we were able to provide only 1 picture, so I will introduce them later. Here, after the keynotes, you have the coffee break. Here you can go to the posters with your coffee and put your dots. Then we have a session on knowledge graph and large language models. This is the 3rd time we have such a session because the large language model or GenAI topic is super interesting, especially in the knowledge graph and semantic web community, because knowledge graph can add additional features to knowledge graphs, and topics like graph rag are super interesting. So we have a special session for this. Right after that, there is a session on the future knowledge experts. In this session, Professor Martin from the TU Chemnitz will provide an overview about the semantic web and linked data courses on 4 different universities. So get you an overview, what you see on the posters, and so you know the results and you know the vision and the idea behind these lectures. Then we have a lunch break, and also in the lunch break you can go to the posters and add your dots to the posters. After the lunch break, we have a session about use case in industry and administration. I'm happy to say that the first time we have a talk from someone from the administration of the city of Leipzig who is using knowledge graphs, so this is something new here. And after this session, again, you have a break, but this is the last chance to put your dots on the poster. Because in the next session, we will count then the dots and prepare the prizes. In our last session, beginning from 3:30, which is named Ontology, Engineering, and Semantic Technology, it gets more technical, and we have 5 talks from colleagues from Leipzig and other areas in Germany about this topic. But this is not the end. We will prepare the poster winners and do a closing ceremony after that. But then I would like to invite you to the Semantic Beer Garden, which is 800 meters away from this location. It started at 6 p.m. and yeah, we can close the day with a beer and some snacks and talk about future work. So I invite you all. So let's start with the first keynote. So the first keynote is named Using Knowledge Graphs in Document Cloud Native Products. It is held from Martin Blumbach. He is the lead architect for automating technical documentation at Ericsson, and he will do this keynote together with Marcel Fröhlich, who is Director of Services at eccenca GmbH. And yeah, I'm happy to have you here and welcome you to the keynote. Thank you.
Ja.
Könnten Sie bitte kurz die Leute, die sich angemeldet haben, in den Raum 259 schicken?
Okay, ich werde gefragt, ob ich jemand, der zum Thinkathon will, in den Raum 259 möchte.
Genau, weil der findet jetzt statt. Also wenn Sie daran teilnehmen möchten, dann kommen Sie bitte mit uns mit. Der Thinkathon findet in Raum 259 statt. Wenn Sie jetzt daran teilnehmen möchten, dann kommen Sie bitte mit uns mit.
A little note from me. For questions after the presentations, please use the microphones so that the stream can hear it as well. Thanks.
So, anybody left for the Thinkathon?
Any other events?
Yeah, so welcome to this presentation in which we want to explain how we use knowledge graphs to document Ericsson Cloud Native products. And we, that is me, Martin Blumbach. I'm working as an information architect at Ericsson.
And me, Marcel Fröhlich. I'm running customer engagements, consulting services for eccenca, and it's really a fantastic use case of building a rather complex application on top of knowledge graph infrastructure. So let's go. In the background, you see not the eccenca headquarters, but the Ericsson headquarters in Stockholm. We'll give you a brief overview of our both companies, tell you what the problem is that needs to be solved, what kind of software infrastructure was chosen to tackle it, the data, the models, some examples to get an idea how everything is woven together, and then just some conclusions. Is it good? How does it work? Why does it work? What were the learnings during the process? And obviously Q&A for you. Next, we'll have a look at Ericsson.
Yeah, so Ericsson, Swedish company headquartered in Stockholm. Ericsson enables communication service providers and enterprises to capture the full value of connectivity. And we are around 100,000 employees in most of the countries of the world. I'm coming from a development center in Germany, and it's maybe important to understand that Ericsson produces a wide range of products. What you see here is a radio dot. It's one of the smallest base stations you can buy. It's an indoor base station, but you know the big ones outdoors. And what we are going to present is not about these base stations. It's about the core network products, that is large software products, basically connecting these base stations and making what you do with your mobile phone possible. And these software products are in their latest incarnation, that is 5G core network, based on cloud-native technologies, that is Helm, Kubernetes, Docker, and so on. And in this presentation, we will not talk about the details of cloud-native, but we will talk about the complication that creates for documentation. Two fun facts, maybe. Ericsson is not making mobile phones anymore. I usually get this question asked, especially from people of my age. So that is not the case anymore. And second, in this presentation, I might say CPI. CPI is an Ericsson acronym for Customer Product Information. That's what I use in my daily work, but it means basically technical documentation. So the manuals we produce for customers to use the products. And it's not 10 pages, as you might imagine. For these core network products, we're talking about 10,000s of pages or so. Marcel, eccenca.
Eccenca. So probably people from Leipzig know eccenca. So we're a pioneer in semantic web technology, headquartered here in Leipzig, also partly running this event. We've been around for more than 10 years, gradually building up our semantic platform, eccenca corporate memory, and either wise foresight or just good luck with the current advent of AI, suddenly all of the things we built that were sort of more not mainstream stuff from an industrial perspective suddenly makes a lot of sense. Customer-wise, we started out primarily in the manufacturing space, always mostly centered around use cases with product information in different flavors. The other sort of big chunk of projects is about infrastructure and security topics, so different verticals, telco infrastructure obviously, and also life science, pharma, and still manufacturing is what we basically are addressing in the market. New customers are in the energy space, so looking forward to present a more complex case of what we do or what our customers do with the software that we provide. So what's the problem that we solve, Martin?
The problem is with the clicker. The problem is how to create technical documentation for software products which are flexibly assembled from microservices and which are independently and frequently released. And you see a depiction of that on the right-hand side, so the product in orange, and then it is assembled from, in this case, 3 little blue microservices. In reality, it's more like tens of these. And then there is technical documentation for the product.
What's special? I mean, there's nothing special about building products from parts.
Yeah, right. I mean, humans have been building things from parts for thousands of years, right? And And it's, in a way, engineering 101 to build products from smaller parts and basically divide a problem, then solve smaller problems and reiterate that. That is engineering 101, right? But the problem here is with the adverbs. Flexibly, independently, frequently. And that is really problematic for documentation. And I want to explain a bit what kind of problems these adverbs create. And I want to do that from the perspective of different roles. So basically from a development manager who wants to develop microservices with high development frequency and wants to release them maybe every 3 weeks so that you can have fast return of investment. And then the product happens as kind of sampling of the available microservices. So somehow you need to manage the content, I mean the documentation you want to produce per microservice to keep track of this too. Second, if you create a larger set of products, you do not want to reinvent the wheel. You will have common functionality in all products. That's good for customers, and that's also good for development efficiency. So you create a platform, a set of microservices used in several products. And that is a very good and valid development strategy. You find that in cars also, right? For documentation, that means you have to think about an enterprise-wide content reuse strategy, because the platform tends to be in one organization, the products on top in different ones. How can you reuse content or documentation across these borders in a way that you can still make sense from an end-user perspective? And the nasty thing is this platform tends to be highly configurable because it needs to serve different products. So how do you create highly configurable documentation? Next. Typically, when you say flexible assembly for microservices, product managers start to get ideas. And they start to think, okay, then I can create not only the 2 products I have, I can mix and match the microservices. So maybe I have 6 products now I can sell. That's very good for the, let's say, the Ericsson. It's also good for customers, you get specialized products. But from a documentation perspective, how do you deal with that? I mean, you cannot hire 3 times as many people to have cover instead of 2 products, 6 products. If you say I need 3 times more people, you'll be told, no, deal with it. The software guys also do it. So all this variant handling, how do you automate in this situation? And usually at this stage, when you show all the problems, somebody comes along and says, okay, I have a very clever idea. We produce 1 document per microservice and we give all the documents to the customer. And you don't even need to try that. That's simply nonsense, because product documentation looks as a product as a black box. You do not document individual parts. You document the product as such and use cases across the product. You assemble information across the product from an end user perspective. So this is not a solution. It will not work if you try that. Also, it sounds very charming to management at times. So if these are the problems, let's think about solution, basically. And I propose this as a requirement for a solution. Manage all content per microservice, because that is the entity based on which you develop. So manage all content, all documentation snippets per microservice, but automatically assemble it from the perspective of a product user. That sounds like a good requirement, but to do that in reality is rather difficult. And if you look a bit at the solution space, then I mean, we already talked about this one document per microservice solution, and that's naive. That will not do the trick. Then nowadays, often you have managers who say, okay, then we use just GenAI from their ChatGPT experience. And that, I mean, that in this way also doesn't work, because you need, for complete and consistent documentation, you need ground truth. And GenAI also needs that. So the real story is something like this. We automate using knowledge graphs, we create ground truth while we do that, and maybe then there is a step where we can basically orchestrate automation and do ad hoc interaction with knowledge graphs using GenAI, and that could be based on model context protocol, for example, exposing knowledge graphs. In this presentation, we are not going to talk about this possible next step, but on our experience, how we create knowledge graphs and use them to automate technical documentation. But the possible next step is something which obviously is also around here and will be around here during the day in some form. Yeah, solution. So this is the solution we came up from a tool perspective. You basically see on the left-hand side 2 repositories. Our content management system, which is a DITA, Darwin Information Typing Architecture content management system. It's not managing documents, but smaller, fine granular information. And then we have an Artifactory as a repository for all kinds of development artifacts which we want to reuse, like configuration files and so on, so that we don't have to basically read them and translate that manually into what is in the CMS. So it's a multi-source content management approach on the left-hand side. And on the right-hand side, we have several delivery channels, at least potentially. One is what we have always done. It's a delivery portal based on HTML with documents. We think about replacing that, which will bring us in an intermediate situation where we need to support 2 of these. Then we want also inbuilt help for graphical user interface products. Most of the products we're supporting are not graphical user interface products. And then we want to reuse all the content we have in different contexts. For Ericsson service, for Ericsson support, we want a digital twin. We want to reuse information in GenAI. And there's maybe many other areas where we want to reuse the knowledge we have in technical documentation. So we're looking at a multi-source content management, multi-channel content publishing scenario. And what do you do if you're a good system engineer? You go to the whiteboard, you draw a box in the middle, you label it AMO, a miracle occurs, and then you leave the rest to implementation, right? And the box we are using, didn't call AMO, we called it Knowledge Graph Platform. And it basically ingests all the information on the left-hand side. And then it automatically assembles knowledge graphs, and it builds documentation on top of these knowledge graphs. And it can do a lot of other things as well. And we based the whole thing on eccenca corporate memory.
I would expect there are also out-of-the-box solutions for that type of problem on the market. So as a sensor, we are highly interested to better understand why you picked the sensor as a platform as compared to something bespoke on documentation.
Yeah, we indeed looked around a bit. It's not so that we thought, let's buy eccenca software to solve the problem. We looked around at the market, and our main requirements were we wanted to automate workflows ourselves in a low-code environment, because we believed that was the only way to economically do that or practically do that. That was one requirement. We knew that we wouldn't find something you can just configure to do that. We were pretty sure that you would need to yourself create workflows to do this. So that was one requirement. Another one was we wanted something which was not documentation specific, because we believe this is we have an overall enterprise digitalization issue, and if we have something we can use for other use cases which probably are connected, it would give us a good way into the future. And last, we wanted native RDF support and a separate graph database, and that is based on GraphDB here. You can argue that you could export RDF also from some other solution, but it was important for us to separate concerns, but a dedicated and good RDF database. And when you look at the market, and after 2 prototypes with different companies, actually, we ended up with eccenca, and we haven't regretted it since.
Okay. On the next slide, I will give you a bit of an idea of the shape and the size of the challenge at hand. This sort of building blocks of different microservices that can be put together, we're talking of hundreds of complementary microservices that can be assembled and provide orthogonal functionality. That adds up to literally 10,000s of configuration parameters that are partially also pulled into the knowledge graph. The number of actual software products, sort of assembly structures created with these microservices is not that big. So we're talking about several dozens of these, with each of them being sort of core network infrastructure, quite complex in itself. On the content side, there is a central repository sort of describing templates of little content chunks with metadata, and there are also more than 100,000 of these. And all parts are moving constantly, so there is daily reconfigurations, updates, new revisions of components, and that needs to be constantly reflected and updated for the downstream processes. And for each of those products, there is potentially like up to 100 different types of documents that can be generated per product. So manually keeping all these moving parts in check is literally not possible. And out of the box documentation automation tools usually just take a different set of assumption on what automating product documentation is. So it's very often more about less complex products and more of these, compared to here we have not that many products, but each of them highly complex and configurable. And we'll just have a look next at how to create and update these content pieces on a per microservice basis, and probably tell a little bit about DITA, because we had this presentation previous more towards a publishing documentation audience, but here DITA is probably not really well known.
Yeah. So we moved a bit from the, let's say, the tooling side of things into the data side of things, and I think that the data side is actually also the more fascinating part of the story. So this is now, if you remember the slide with this content delivery pipeline, on the left-hand side, basically, we had 2 repositories, the content management system and Artifactory. And now we are looking a bit at the artifacts which we have in there. And the first thing is in the content management system, we have DITA topics. So what are DITA topics? Think of that as chapters in a well-structured document which can be repurposed in a single sourced manner in different documents, basically. And each of the topic basically answers a single user question. And DITA is an open standard, kind of industry standard by the OASIS committee, originally from IBM, I believe. It is basically, we have text in there which is written by tech writers for consumption by human beings. But it is not text only. It's an XML DTD. It's highly semantically expressive. Even the topics have types which are machine readable and structures which depend on the type. So there are concept topics explaining what something is, task topics explaining how to do something, troubleshooting topics as a specialization of task topics, and reference topics. And you see, and probably you cannot read at all on the right-hand side such a snippet, but the main message is it's maybe half of this is XML elements and half is text at the end. So it's a bit like a programming language. It's not, documentation is not text really, only. Yeah, and when we ingest that into the knowledge graph, we basically ingest the topic metadata we have. Not the whole topic, with exemptions. So that's one type of input we have. And second, we have that what we read from Artifactory, and just to have a good name for it, we call it structured data modules. We try to convince the development organization that this has to be handled according to fair data principles, so findable, addressable, interoperable, and reusable, but that is quite a challenge. I mean, they produce their configuration files for the use of the software, and you even making it findable in a consistent manner across many organizations is an issue. They don't need that. And addressable, same problem, but the real problem is interoperable. So you have very many configuration files, but they talk about the same thing, but in different language, and you cannot cross-relate things between these. And getting such kind of impacts into development artifacts is a difficult exercise. So in essence, these structured data modules contain machine-readable facts. Is also XML, but not DITA. It's more XML for machines. Hopefully with a well-defined schema like a DTD or a JSON schema if it's JSON. And we use and ingest this to instantiate the knowledge graph, basically, and with knowledge about the product. And you see on the right-hand side an example of this, which is probably also difficult to read now, but that is basically a small JSON file snippet. Yeah, so this is the data we ingest. Now, how do we fuse the data with knowledge? We use an ontology. It's an RDF ontology. What's in this ontology? First of all, the product, of course, and the product from a customer perspective. You can represent the product from very many perspectives, but we represent it from the customer's perspective. So what is important for the customer to operate such a product? And these are things like, how can I configure this? Typically we have models, not graphical user interfaces, configuration models. Then alarms, certificates you have to manage, counters and log events and all these type of things which are relevant to understand how you can interact with the product. So that we represent in the ontology, and second we represent knowledge about the technical documentation. So the metadata of data topics, then the hierarchy in which we want to arrange the topics we have created. We cannot just throw them as a bulk thing at customers, so they have a way to be arranged. And then, of course, publishing system related entities, so automated publishing.
Okay, so that's what's in the ontology. From a design perspective, it's also relevant to think about what to put not in the ontology. With all that much of information that we just described, there is always a certain urge to pull this information together into the knowledge graph, but that's usually not what leads to good results. So thinking about the purpose and the expected outcome, the sort of questions that need to be answered from the knowledge graph, when you start thinking about things of this size, it's really important to sort of work out what is the actual skeleton of information that you need. So don't do stuff with respect to ontology and data just because it's there. Think very hard about what you don't need and need not represent and just can drop from the discussion. There will always be people involved in the discussion who are responsible for certain aspects, and already prepared a little piece of ontology where things are in that look interesting on first sight, but if it's not strictly required downstream, just drop it. So ontologies are about compression, ontologies are about dropping information, ontologies about sort of finding common ground to put things together in one box, like mathematically speaking, sort of homotopic classes, and boiling this down to the max is what will be sort of paramount for successful usage downstream when you build something big.
Yeah. And then we have a little ontology development process. We haven't invented that really, but for me it's important that we, as Marcel says, we go from what we need to express. And we use competency questions to basically define what questions the ontology or the knowledge graph should answer at the end. And from that we go to a graphical depiction so we can discuss the ontology updates with subject matter experts, and from that we go to RDF modeling basically with a bit of all. I think it's important to strive for modular ontologies, not to put everything in one huge ontology so that you can independently update parts. So for example, we have a separate product and information ontology, and there's a bit more to it. And then creating ontologies is not only a technical thing, it's also a lot about bringing people together. And the people will have very different competences, and you can have endless discussions about ontology design. So this is a challenge actually to have an efficient, collaborative approach between people who know different parts of the story. And that can be challenging, really. And it can also lead to that your ontology is full of stuff you don't really need. Yeah, so I think we understand a bit the data now we are ingesting. We understand the ontology. How do we instantiate the knowledge graph? We use, here's an example of the ontology, or of the knowledge graph, of the ontology actually. Now here we see how we actually instantiate the ontology or create a knowledge graph. And we do that with eccenca workflows. And we go from the data on the incoming side per microservice and microservice release to, in green, to basically the documentation we want to publish in red. And that is, we need a publishing specification, we need the documents. We actually auto-generate also data book maps, which is a term for documents at the end. We also auto-generate some topics from the structured data we ingest so that it mixes and matches well with human-written stuff. And how we go from left to right, we first ingest information on a microservice level for every release, and we build these little baby knowledge graphs, if you want, which represent a microservice in a given release. And we put that in a huge knowledge graph, which is we call a building box knowledge graph. It's kind of everything which could be, if you want. And from that, you can build a product. And we do that in an automated manner. So we use the Helm chart of the product, kind of the build manifest, if you want, and which defines which microservices and which versions are used, and also how they are parameterized in this given product. So this brings all the product context to it, and we use it to assemble from the individual microservice knowledge graph a product knowledge graph, which represents the knowledge about the product. And on top of that knowledge graph, we then run basically the output generation. So product knowledge graph kind of is a byproduct, if you want, of the need to automate documentation. We create one product knowledge graph for every product and every release of the product, and we do that automatically.
Yeah, so just to repeat one more, it's important to understand there is on the left-hand side, one big knowledge graph of sort of the possibility space, and on the right-hand side, we only depicted one, but there is literally hundreds of those big boxes that represent the actualization of these possibilities for a specific product. So just this split, what was the rationale of this?
Yeah, between the little baby knowledge graphs and the big product knowledge graph, right? So the idea is basically a shift left approach at the end, like a development shift left approach where you avoid a big bang approach with integration at the end, putting everything together, and then it fails miserably. So at every time a microservice is released, we try to quality assure the microservice level knowledge graph in as automatic way as possible. And you can actually, we're not doing this, you could fail the release of the microservice if the data is not okay. So that's one thing, and the other thing is it's an efficiency approach because you don't want to create these microservice level stuff each time you have a product which uses the microservice in the same release, right? So you create that upfront, you quality assure it, and then from the pieces you can build this big product knowledge graph, which then one per product and one for each release of the product, basically. That is the rationale.
Yeah, let's look at one of these. So one of the right-hand side boxes a little bit closer.
Yeah, let's look at some examples now. So this is a tiny snippet of one of these product knowledge graphs. On the top, in this blue product line, you see the product part, and it basically shows 3 microservices. It's in reality 30 right now, it will be 100. And you see that microservices implement one function. There's an end-to-end relation between the microservice and the functions which a customer sees. You don't explain the product in terms of microservice, as we said. You explain it in the terms of exposed function. This is a very simple function, user management, that you probably all know from daily experience. And that function exposes interfaces. So for example, it has an LDAP client to connect to a central LDAP server. And that is very central information when you want to do user management. You can do central user management, LDAP client, there's a secure and an insecure version. The insecure you should configure. And you need certificates to basically protect that on protocol level. And these you also need to manage. That is relevant customer knowledge. And there's quite a lot more things you want to know about user management. Which alarms are there, for example? And you want to know details about the interface. How do you configure the target port? And so I haven't put this all into this figure. It would have basically been a semantic hairball at the end. But it gives a high-level idea how this looks like. And then there's a second part of the knowledge graph, which is about the documents. Also, we don't know let's say, the publishing details at this stage in the product knowledge graph. And there we basically have a, can I use this? No. We basically have a topic hierarchy as an order tree, so it's like a document table of content structure which arranges the topic in a document-like manner. And we do that per function. But there's other relations between the topics at the bottom here and the product, which I don't show here. And it's important that we have, for a product, we currently have tens of documents. It will increase a lot when we further expand the approach. Yeah, so that is the product knowledge graph. And then what is also nice with corporate memory, you can basically create information designs to help people understand the knowledge graph. So you cannot show the knowledge graph to people. It will be just a huge semantic hairball. You can maybe slowly explore something, but for example, for a group of people, in this case system architects, you can do an information design which basically explains the most important surfaces, the most important facts for these people. So what we have done here, we have basically created an overview diagram in corporate memory with this an Apache E-chart Sankey diagram where the basic facts on the left-hand side are the functions. In the middle, the microservices is for system architects to understand what's composed of. On the right-hand side, the interfaces and their relation. And Sankey diagram do this relatively well, this relation. And then we have tables, nice configurable tables actually, where we have the different entities like the microservices, and I think the interfaces, and further down then we would have like certificates and alarms and God knows what. So it's an information design for a specific group of users to understand from their perspective what is in the knowledge graph. As configurable in corporate memory.
Yeah, probably worthwhile mentioning the configuration of those information designs is at the core driven by shackle constraints that you will do anyway. So designing or documenting the data structural constraints is repurposed also for presentation needs. Doing shackle is being used for helping configuring those tabular style front ends, helping taking design presentment decisions in the graphical representation, and obviously also for validation purposes.
Yeah, and then, this is difficult to see, and you shouldn't, it's not for you to read this, but this is how we actually instantiate the knowledge graphs with eccenca workflows. So this is what you see is basically one of these graphical workflows which runs the initial ingestion, and in reality it's 1/10 of the workflow we have created. And you see that it consists a lot of plugins or operators chained together in corporate memory, and we have also amended it with documentation on the left-hand side and on top. I mean, it's kind of self-documenting with these low-code workflows, but you realize that you need higher-level documentation as well in this when it grows to this size. And corporate memory has a lot of inbuilt plugins, but we also realized that some things we had to do ourselves. So we developed, like, I believe 5 Python plugins. I was mainly in the area of complex REST API interactions we have, and then YAML file handling, which is a kind of Helm specific thing. You cannot expect to get everything out of the box if you have special use cases. And the APIs we are interacting are of the subscribe notify manner where you have to wait quite some time, and that we had to implement ourselves, which works quite nicely actually. And we run this ingestion workflow maybe for a few figures. We run this maybe 10 times a day currently. That will also increase. This product assembly we currently trigger at 2 times a day. We currently have 2 products in there. This will increase as well. Yeah, and we have these Python plugins as well. These were the 3 examples I wanted to show. Basically, the snippets of knowledge graph, then information design for system architects, and then how you actually do that practically in corporate memory.
Okay, let's come to an end slowly, fastly.
Yeah, so some kind of summary. I'll click quickly through this. This is looking at benefits for different roles, and it's basically telling the usual story. If you automate things and do it in a consistent manner, then you have efficiency gains, and from an end user perspective, you just have a different product at the end. In this case, an information product. That's most of these boxes here. Maybe one box is special here and important to understand, and that's the GenAI box. Because what we also realize is if you have to do documentation in this environment we are in, it's difficult to do it in time in a good way with all these things moving all the time. You get lousy AI performance also. I mean, if you put the documentation in a RAG database, start asking questions, you get lousy answers because the input is not good. So this is also, at the end, it improves the data available to GenAI. And if you not just use a RAG database, but use something like the knowledge graph itself, we believe it will get even better. Learnings. So it's a marathon, it's not a sprint. And that is a problem because if you do something with LLMs, you get things can show very quickly. The problem is you cannot productively use it. It takes a lot of time to use it productively. But you have something upfront very quickly, and management, you can basically engage management on these things. This needs a lot of upfront work with knowledge graphs before you can show something. And you have to be really perseverant to get this to work. It's not easy. And you need collaboration with different organizations. You need buy-in. You will not always get that. So this takes a lot of time. It has taken us now 1.5 years roughly to be where we are, and there's a lot more things we need to do. We basically cover this configurable platform right now, which from my perspective is the biggest complexity in it. Second, when you can reuse existing artifacts, do that. Try not to create own artifacts because you will affect other people and you will immediately have a business prioritization discussion in an enterprise. And it might be difficult to prioritize your requirement. It is in reality. You're competing with feature development. And that brings the money to the company. So you have to make the business case all the time. Even if it's positive, it might not be good enough. It's competing with the kind of the enterprise business when you do that. So it's best if you can reuse artifacts, but often they are not good enough. Interoperability for fair data, that's really a problem. Marcel said that only model what you need, not what all the involved people know. You will have a very huge ontology which you will not understand anymore and you cannot use, and 1 year later it will anyhow not be what you need. And last, it's not really about tools at the end. It's about good data. It's very difficult to get good data in reality, and it's about people. So it's not something I'm doing alone. We are a small group, and you need really good people to get forward with this, and you need a lot of collaboration. So you need people who are also good with collaboration. That's what I wanted to say. How does that match your experience with other companies, Marcel?
Completely agree. So people need to understand the information that they're seeking are not in the data. So it's not a puzzle. It's more like a negotiation process that has to be passed. And process worthwhile because that will provide you the knowledge in a formal way that can be used downstream for automation.
Yeah, thanks, Marcel. So I think we are at the end of our presentation. I believe we have like 3 minutes for questions. So please use these microphones over there if you have any. Marcel and I will also be around during the day if you have questions.
Yeah, thank you, Martin and Marcel. There's a question. Okay. You can also.
Okay. I had 2 questions. One was about data quality assurance, but I think, Marcel, you already answered it. You use shackle shapes for each of the baby knowledge graphs. I think you mentioned, you called it that way, to assure quality. And the other question I had in mind was, you develop a schema for each of the functions or microservices you ingest. Can you give us some numbers about the number of classes and relationships and chuckle shapes you use. And you also mentioned OWL. So what do you pick from OWL into your knowledge graphs that you haven't found in RDF?
Yeah, I had some hidden figures here. So on the top right, we have currently around 50 classes. So we don't have one class per microservice. We have a microservice class. We have a class for released and for a microservice in general, and one class for released microservices. But the individual microservice and their releases are instances of these classes. But we have around 50 classes for this. And there is prominent ones like microservices, alarms, functions, and so on, but there's also smaller ones. And then we have around 140 properties. I'm not sure now how many are object properties of these. And the knowledge graph itself is relatively small. It's actually 100,000 RDF triples in such a product knowledge graph, but you have many of these.
Exactly. So we're looking at the number of triples for one of the boxes on the right-hand side. So this does not include the large building box, and there's many of these. Yeah. So this is sort of the triples for the customer perspective on one product. Customer not being a GUI end user, but user of sort of network product.
Question answered. So are there more questions? So I have a question. Is reasoning any topic in your knowledge graph?
Not right now. I doubt that it will become one. The fun thing is, before we partnered with eccenca, we had a collaboration with the University of Manchester, and we actually had an old ontology, and we were discussing reasoning and for various things. I'm not sure if we will practically do that or need that ever.
I mean,
linking is
exactly.
an issue, and maybe GenAI is also a way to do linking where it's difficult. I don't think we will use all reasoning in reality. That is my current view.
Okay, thank you.
I think in a way the linking that we do can be looked at as a bespoke form of reasoning, actually.
Okay, so thank you very much, Martin and Marcel again. And I would like, there is a question. Can you go to the microphone, please?
I feel we are running out of time, unfortunately. But why didn't you simply use YAML interface specification or ERP documents or class diagrams for documentation? What is the real benefit to switch to knowledge graphs? I don't just ask it for kidding or something like that, because it's a trend, I know. But what's the real benefit that you switch to this technology? Is it why we're on the data week now, or what is the reason?
Yeah, I think the reason is the customer needs. I mean, documentation is funnily about minimalism. That's not so well known. So you give to customers only the information they need, but nothing else. So which information is needed? And to operate these products, and in this case, it's not a YAML specification, it's a model. There's a configuration model which you can render and which you need to assemble. So you need to assemble the model files. Then you need conceptual explanation of the model. What does that mean, really? And you need tasks which, in which you achieve an end-user goal. So a YAML specification, maybe a Helm, a part of a Helm diagram is part of deployment of a product that can be given to customers, but it's a very small part of it.
Just apply a filter.
Sorry?
Or just apply a filter on the specification or a transformation.
It's not good enough. I mean,
and probably you did it before, in the years before knowledge graphs become prominent.
Not at all.
Not at all?
And it's not what our customers are asking for. Our customers are asking for conceptual explanations. What does it mean? They are asking for, how do I do this? Adjusted specification might be good for a very small product and for deploying it, but it's not good enough for operating and troubleshooting it.
Okay. You mentioned that knowledge graphs are the new data source for information or for architecture. Who is watching or looking at the knowledge graphs at all? Is it just another data source which will be ignored by developers? Or what is it good for, to store these knowledge graphs? There are many knowledge graphs, of course. Who has the eyes to look at that for a long time and continuously?
Maybe. So in this case and in many other cases, it's actually about bridging the gap between structure and function.
Okay.
So all the things that you're talking about are very much about structure, what's in it, what are the microservices, how are they composed. But the rationale of why is not answered from that perspective. So what is the purpose and function is usually something that is coming from completely different streams, like requirements, documents, and the like. And if they are then integrated into a whole, into a product, we see that in many cases, that's the step where information gets lost. So, for example, in engineering, the engineers get all the specs, do something because they're so skilled, build something together, and then there is a machine with a bespoke structure, and there are some knobs and buttons and display and whatnot, that have a relation to those original requirements, but they are usually sort of separated out. So in the database is about the product, that's sort of like the structural view, and to bring that back together to be able to give a user perspective on a product. What is this button for? What happens if I press it? In which situation am I supposed to press it? That's not in those structural repositories represented at all. And we bring this together not for people to look at the knowledge graph, but to have this knowledge graph as a basis to automatically create human readable content, text. So it's about actual documentation texts that are assembled in different formats and ways, either context specific or also in like that documentation that fulfills the regulatory requirements to have actual documentation being delivered with the product.
Okay, thank you. I have several more questions, but we are running out of time.
Yeah, we are running out of time. I will ask you to continue this in the break, which is after the next keynote, which I would like to introduce now. So thank you very much. So Sebastian is preparing the slides already. So the next keynote is from Dr. Andreas Pavlik and Kai Kümmel, both from Carl Zeiss, but from different companies. Andreas Pavlik is from Carl Zeiss AG, and Kai Kümmel is from Carl Zeiss Semiconductor Manufacturing Technology GmbH. And the keynote is about leveraging knowledge graphs and GenAI to transform enterprise data into actionable insights. Thank you very much.
Yes, so a very warm welcome to all of you. Thank you to the organizers for having us, and of course, thank you to the audience for joining us in today's presentation. My name is Kai. I'm leading the data enablement project at Carl Zeiss SMT, which is part of our digital transformation. And I'm joined today by Andreas, who will quickly introduce also himself.
Yeah, I'm Andreas Pavlik. I'm in a central unit supporting. Sorry, yeah. I'm Andreas Pavlik, also really great and excited to see you here. I'm in a central unit supporting our business units in developing the data journeys. And so I'm really excited to share this presentation here with Kai Kümmel, who will continue with our presentation next.
So the presentation is split into 4 parts. First, I will quickly introduce to you Zeiss as a company. Then I will shed some more light on the SMT products, and from there derive the challenges that we are facing today and that we are addressing today. So that gives you a better of understanding how what we are explaining to you affects our products, and to some extent extends to all of you, so that there's an impact most likely to a lot of the people in the room already. After that, I will hand over to Andreas also that he can share some more lights on lessons learned and next steps. So that will hopefully also can transition to a nice discussion afterwards. So looking forward. So some nice facts to start. So at ZEISS there are about 47,000 people working in about 100 locations in 50 countries. And last year we reached almost 11 billion euros in revenues. You may know that ZEISS is a portfolio company consisting of multiple SBUs, so business units. Those are the 4 important ones. You have the Semiconductor Manufacturing Technologies, SMT. So we do like 3-letter abbreviations, so stick to that. So SMT, where we are producing optical systems, not chips. We are not producing any microchips. We are producing optical systems that enable our partners and customers to build the world's most advanced microchips. Then we have Industrial Quality and Research, IQR, where you find advanced metrology and microscopy solutions. At MED, Medical Technology, you find solutions for ophthalmology and for microsurgery, so you could say nose upwards. And last but not least, we have the consumer market segment. Maybe many of you are most familiar with. They are producing eyeglasses, such as those I have, but also photo lenses. So maybe this is the point where many of you have already interacted with us. Now a bit more deep dive on our products at SMT. So they are looking like this. And for instance, they are used in the lithography systems you maybe know from ASML, but they're also products for photo masks, metrology, measurement systems. And we're doing this for quite some time. So starting in the 70s, they reassembled somehow photo lenses. So they came from there and they looked quite like it. And they were fairly small. They have a person holding them, quite nice. Over time, they're getting bigger and bigger and bigger, and of course, much more complex. And a fun fact, the product that you see on the right-hand side, the Starlit 1900 series, is still up to date the best-selling size product. Now you could ask, why is it so important to improve those optical systems over time, right? And the reason is quite old. So it's almost as old as ZEISS as a company, and ZEISS is over 175 years old, and this formula is pretty much 150 years old. It goes back to the relation between the wavelengths and the numerical aperture to the resolution of your system, which means the better the optical system, the smaller the objects are that you can print on a wafer, right? And the smaller those objects, those structures, the more powerful the systems are, or the chips are, the smaller they are and the less energy they consume. So you have a win-win-win situation. So that's why this is so important. And regarding the wavelengths, you see that it evolves from the deep UV, so deep ultraviolet light spectrum, ending up at the 193 nanometers that you see that you saw on the right-hand side. And there was one quite important step just a few years back, that we could go to extreme ultraviolet light, wavelengths of about 13.5 nanometers. And with those systems, we were able to produce structures that are 5,000 times smaller than a human hair, which is, I would say, quite small. So, but it comes with a catch. So the smaller the structures are that we can project, the bigger the systems get. And I really mean big, so tens of thousands of individual parts, multiple tons of weight. So I really tried, but I couldn't bring you something of this here. So it was just not feasible. And this is not just challenging from the engineering perspective, this is also really challenging from a data perspective. So transitioning now to more the problem space. So we have a lot of highly specialized, but also decentralized data. And to even solve day-by-day tasks, we need to complex multiple very complex data sets and data sources. even identifying the appropriate data for your task can take a lot of time. And after you got it, it takes a lot of effort to identify the knowledge that you need. And this is usually split around multiple divisions, needing multiple experts to just accumulate the knowledge to then consolidate the data fit for purpose. Right? So and this is not something that we have figured out in a brainstorming session. This is the outcome of interviews we conducted with the people most evolved by it or affected by it. So what we are aiming for is to allow true self-service exploration of our data, so that you do not need to ask a lot of people to find the data that you want, but you can do it yourself. And also, and this is as important, that we can publish and share data products that are fit for purpose, that are consumable as they are, consumption ready. Because else you have the problem that some activities, the same experts are questioned and are interviewed for the same or quite similar activities. So these are, I think, the two most important parts we try to achieve or we want to solve. So and how we do that, I will hand over to Andreas.
Thank you, Kai, for this introduction to the business challenge and also for outlining the target that we want to accomplish. And yes, as you mentioned, I will now take you on the tour through our solution approach and through our implementation of this solution. In a nutshell, our solution is based on an innovative combination of 3 technologies: data catalogs, knowledge graphs, and large language models. And this slide shows why we do it like this. So initially, in the beginning of the project, we thought to accomplish our goals, data catalogs are all you need. So we started exposing information about our data sets in the data catalogs, and this gave us immediately full transparency about the available data, the schema, the technical lineage, and so on. And we had beautiful, really easy to use user interfaces through which users could explore this type of data. And then we interviewed our users, and then we found out that's not how they like to search. They often want to search for data using logical dependencies, not in the data catalog. So examples include something like this. I want to find a data set that comes from a specific manufacturing process under certain conditions in this factory with that machine, right? And this is the challenge. And when we heard this is when we thought, now we need to introduce knowledge graphs. And in knowledge graphs, we then integrated the technical metadata from the data catalog with these logical dependencies to address this business question. But then we had another problem. So knowledge graphs are not easy to use, not by the end user. And this is when we added large language model to our mix. And through these large language models, we could build powerful conversational interfaces that let users explore the knowledge in these knowledge graphs. And we paired this with visual interfaces that then made for a really intuitive exploration of the available data sets. So the overall approach now lets us tailor the searchability towards the knowledge levels, the needs of the users. It simplifies really also complex searches, and it enables what we are after, namely self-service, self-exploration of the data for analytics cases. So how did we implement this? Our implementation is based on a semantic layer that is ontology-centric and that makes for an architecture that we call knowledge-infused agents. And at the core of this is indeed the ontology. The ontology interlinks and harmonizes the information sources and makes them available in a structured representation of our domain knowledge. It makes this knowledge accessible to both humans and machines in a highly understandable way. By establishing clear definitions and relationships, the ontology ensures that users understand the context and the meaning of the data they encounter. The ontology in the system is then accompanied by an agentic API, and this API now makes sure or translates the natural language inputs of the users to precise data queries. So and this is now really important and really critical to the success of the system, because here is where basically we have the translation from what the user intends to do and the actual data retrieval process. By leveraging the ontology, the agentic API can minimize hallucinations, so that there's risk of incorrect or misleading answers, and thereby we ensure that the users get highly accurate results all of the time. As you can see here, in our setup, the agentic API can have a number of tools to further improve user experience. So for instance, we have an entity resolution tool, which lets us really flexibly search for concepts using fuzzy matching. We have an automated query correction tool to increase the overall robustness of the system, and so on. So in summary, it's the enhanced interpretability that is provided by the ontology in our system that makes it easier for users to understand and make use of the information that they are encountering. The agentic API's ability to translate natural language into precise queries makes sure that users really find information with the least amount of confusion and misinterpretation. And the point about the knowledge-infused agents is that we have a clear separation between where we store the domain logic and where we have the intelligence. So our domain knowledge is mostly in the knowledge layer where the ontology lives. It's highly structured in that layer. The agentic API mostly holds generic or general behavior. So think of your AI, your GenAI agents having prompts, and they contain all the business logic, a very long prompt. In our case, all this information is structured in the knowledge layer, and there's little left, only what's needed for automation, the intelligence, to say, in the agentic layer. And we find this architectural pattern very interesting, very useful for developing and maintaining our core application logic. That's why we're doing that. So this this knowledge-infused agentic system is becoming a blueprint for implementing intelligent systems in our company. It's not the only way of implementing intelligent systems, and we also do it differently. But as we see the value of this approach unfold in practical scenarios, the initial invest that is needed to set this up, and we're talking here about the creation of the ontology in particular, that meets less and less reservations. So we're just doing it. And the architecture has a number of clear features that translate directly into business value, which makes it also really tangible, that it makes sense. So for instance, we have an enhanced answer relevancy through the approach. And the answer relevancy is enhanced because of the knowledge layer, which improves context understanding and makes sure that users get really targeted results. Then we have an enhanced interactivity, and this provides for better user guidance when clarification is needed. It guides the user in their data exploration journeys. And eventually, it does not only help users to find the right answers, but it also helps them to ask the right questions to solve the problems at hand. Then we have automation. The system obviously leads to a high degree of automation, which lets us also do question answering in more complex scenarios, not just one-shot questions. And we have a high modularity. Right? We split off two core parts of the system, the knowledge, which is highly structured, and the intelligence, and that makes for good maintainability and scalability, especially important if you're at the beginning of a journey where you will face changing requirements and you will want to integrate at a larger enterprise scale eventually. So all of these features then give us business capabilities, some of which are highlighted here, and are worth mentioning. We have a scalable use of domain knowledge, and this is really important. It's the foundation of a meaningful interaction with the data. We have an effective solution for answering multi-step problems. So users are guided in the system from the start to the end, also in complex scenarios. And there's a seamless integration of structured and unstructured information. So most systems either let you interact with structured information or with unstructured information. SQL here, GenAI there. In this system, everything comes together and we can explore insights from across a wide range of separated but related, logically interrelated sources. All right, so when we implemented this, not everything went well in the first step, right? We did make mistakes. And so here we would like to share some of our learnings and also success patterns that we found useful. In many of those projects, many of the times, it's the AI, and particularly GenAI, that is in the spotlight. But in our project, it's certainly true that the hero of the system is the engineering. So engineering was very important. Integration was very important. It was essential for seamless functionality, as we needed to rapidly iterate between prompt engineering and ontology design. We also put a lot of focus in automating the quality assurance of the answers that we got from the system. This was super important because we could go quickly beyond anecdotal evidence and start improving against qualitative, measurable, basically KPIs. Through this, we gained the buy-in of our stakeholders, which otherwise would need to rely on our words as developers only, right? There's many other points that I could mention here. But it's also true that you don't need to automate, that you don't need to fully engineer everything, at least not in the beginning. So we certainly had an eye on bringing business value as quickly as possible and focused on proof points that are most uncertain. We mostly implemented automation that added truly value to the project. Like, for instance, when we explored how to integrate with the enterprise. Then finally, how much of this do you build yourself? How much of this can you buy? And in this project, as well as in others, our learning is that in the beginning, you just need to build stuff yourself. And this is to meet immediate needs. There's no other way. This is our experience. It also helps you to understand what's even possible today, right, in products. And that's also a very useful lesson. So then, as the project matures, and the products around it also, then it makes sense to shift focus of development towards the development of the core business logic, right? And adopt as much as possible of the rest out of the box. And in this, let's say, hybrid approach, you minimize custom developments and focus on what you're really truly good at in the long term as a company. And this is your core business logic. Another lesson that was, or an insight that we got from this project, and that was really important and showed the importance of collaboration and innovation projects, is the following. The success of this project depended a lot, and we've heard it also in the other talk, on bringing together people. So really aligning the developers in our team, getting their buy-in, and doing this through a shared sense of ownership and co-creation. In this project, we brought together a couple of cutting-edge technologies, like data catalogs, knowledge graphs, large language models. They are not new in itself, but they were new to us in the team in that combination. And so we anticipated already from the beginning that there would be challenges that would kind of test our patience and also our trust in the approach. So how did we deal with that? We basically invested a lot of time and effort to ensure that every developer, each and every developer in the team, is fully enabled in the process. Nobody is left outside. For instance, we gave effective tooling to our application developers to develop GenAI agents and interfaces on top of the knowledge graph. Our domain modelers wanted to contribute their domain expertise, but they didn't have a formal education in ontologies, and we helped them with that. Then we had data engineers. They needed to map data into knowledge graphs without knowing RDF. And knowledge workers, they just wanted to explore the data, but are not graph experts. So by enabling each of these personas to contribute their individual perspectives, their individual know-how, we arrived at a strong collaborative team and sharing the ownership of the project. And how was this implemented, actually? How did we do this exactly? Quite simply by leveraging low-code tooling. So this really was the foundation. It made technical possibilities accessible to us, and it was the foundation for strong collaboration that eventually then really advanced our project. The takeaway lesson from here is also, we see this in other projects that we do in our company, that it's not sufficient to build architectures that scale out technically. So you must do this, it's necessary, but it's not sufficient. In order to be successful, you need to build architectures that also are adopted, that scale out in terms of user adoption. And so you need to invest time and effort to make your solutions accessible. And this is another sweet spot where we see commercial solutions highly useful, namely in providing effective tooling that let us focus on what truly matters to us. And in doing so, we stop building interesting technical experiments and start building solutions that are widely useful, widely adopted, and highly impactful. So coming to an end, I'd like to share some roadmap highlights that will inform our way going forward, also with the intention to get a little bit into discussion with you. What's on your roadmaps? How do you approach these challenges? And learn from each other. So one focus will be on technical scalability. We need to do that, and we are now moving away from agentic setups to multi-agent architectures, right? And we see already this just gives us a lot more flexibility in our systems and lets us address more complex problems. Then currently we focus with the semantic layer on a highly limited data domain. So it will be interesting to expand this, include additional concepts to integrate more sources and also eventually get interconnected at an enterprise scale. So if any one of you has experience with that, we'd be really interested to learn about that. Then another focus will be technical maturity. We now take the lessons from our pilot and build towards an MVP, a minimal viable product. And this will be really a super important milestone in our project, because from then on, we will continuously create a value, right? A very important milestone for us and our stakeholders. In that, we also want to transform our solution into a platform with self-service capabilities. Then users can basically build their own solutions on top of ours, and this will help us meet an even more diverse set of needs. Yeah, with that, I will hand over to Kai for the last words.
Yeah, thanks, of course. So this is the closure of our presentation. Thank you for sticking until the end. Just one last note. So if you find interesting what we just explained, so then feel free to explore the QR code. We are still hiring, looking for new talent. And that's pretty much it, I think.
Thank you very much. Actually, we have no time for questions, maybe only one question. Can you go to the microphone, please?
Have you considered AI-generated ontologies?
Generally, yes, not in this project. Our experience is here, I think that's super useful to have this new possibility. Basically, to ask GenAI, generate me a couple of concepts. Right, here's my problem. What are concepts that I can start with to build up an information map, a knowledge map? But here it was super much driven by the domain knowledge, right? Even I couldn't really describe the problem. I needed to work together with our colleagues from the business unit to understand what everything means, and so it was really beneficial to get together basically in a meeting or in a room with the experts, draw something on basically on a whiteboard, which may also be just in some tool, right, where you can draw this perhaps more quickly, and go from there, right?
And maybe one addition. So the most important part is that the way we manage the knowledge is trusted by the people using it. And if you start asking the GenAI and then let it be validated by people who knows it better, then just ask them first. So it's a bit, it's the rarest resource in this project is the people that hold the knowledge and their openness to follow our approach, to share the knowledge in the way that we need it, so that it's trusted in the organization. So there, I think it's quite, it extends the complexity and makes it maybe not neither easier nor cheaper to use GenAI at this point.
All right, thank you. Was just curious what you were finding out.
Okay, we are going now in the coffee break. I just want to remember you to go to the posters and maybe bring your dots. And the next session is on knowledge graphs and large language models. So it's more into detailed talks about exactly this topic what we had now. Thank you very much.
once again be here and chair this session on LLMs at the LSWT at the Data Week of Leipzig. Yes, we don't have that much time, so straight to the first speaker. It is Golam Ravi from the Leibniz Information Center for Science and Technology. And he will speak on neurosymbolic AI for scholarly research. The stage is yours.
Okay. Hi, can you hear me? Perfect. Okay. So I'd just like to introduce myself again. My name is Golam Rabi. I work as a postdoctoral researcher at Leibniz University Hanover under TIB and LDRISE both. And I work with Professor Zoran Oer. Maybe you know him, some of you. Yeah. And my research interest is basically working with the neurosymbolic AI. And mostly I'm working on the neural part, not on the symbolic part, as a lot of people I hear knowledge graph and something. But yeah, I also share some knowledge about the knowledge graph and some other things. So currently, I also working with something called science, AI for science. Yeah. So this is basically try to use the neurosymbolic things to enhance the scientific discovery. And my research is also related to the scholarly data and some other things. So today I like to introduce one of our product, or you can say research things. It's called TIB Assistant. It's basically a research assistant for the researcher that can help them to do the research for each of the life cycle in their research. And it also useful for the company in their R&D project or something because it incorporate with the neural and symbolic data, and it can give you the research idea or solve the research problem, whatever you want to do. So, as I said, that it helps the researcher to solve their problems in their research life cycle. And it also flexible, it can be domain independent, and sometimes if you need, it can be domain driven. And the full idea is basically use some subcomponent, or you can say agents. It can be ideation, research quotient, state-of-the-art generation, method, implementation, result section, analysis section. It can also help you in the writing of your paper or analyze of your paper, and help you in the publication process, and also help you in the post-publication process. So, the full assistant or the multi-agent system is basically working with the system prompt. In some cases, it uses the tools, and the tools can be defined by the user or your necessity, because it differs from the domain to domain, from the chemical domain and from like physics domain or computer science domain, the tools can be different. And it also interact with the user. It's not a fully independent system that can take decision by itself. So it talk with the user, and depends on the user necessity, it can give you the solution or some things. And each of the phrase, like the describe phrase I do in the last or previous slide, it can be used together, or you can use it independently. Some people need only analyze their idea for the analysis section, or in the method section, they can use it independently in that part. And this is like a example UI, you can say, because we are working with these things. And in this part, like in the ideation part, you can say that user can ask this system or this multi-agent system with their ORCID ID, because they need some personalized research idea. Because as an example, I work in a neurosymbolic domain, some people work in the physics domain, so they need their idea depends on the their experience or something. You can also use a specific research paper, not from yourself, like from other people's. You can use it, give the DOI. If it is available in different sources like Crossref, Archive, we can extract them. And we analyze this paper. And using this paper, we can also give you new research idea, depends on your necessity. And user can select single or multiple research idea. Like if you want, you can select one idea. If you want, you can select multiple ideas. So this system or multi-agent system can incorporate with different ideas. Okay, so when users select one or multiple research idea, we can take them in our output or asset section. In that part, user can see that are they really interested in this idea or they want to remove or some other things. So they have the full independence that they can use it or they can remove it. In some cases, you can say in more personalized way. Like we are also working in some deep idea generation where user can give their ORCID idea or something and they ask that, yeah, I'm interested in this specific domain and in this sub-specific part and I need research idea specifically dedicated to solve this type of problem. So we are also working in these type of things. Now, after the idea generation, we are talking about the research question. Each of the idea, we need one or multiple research questions, depends on the user thing. So our multi-agent system can generate one or multiple research questions, depends on the selected idea by the users. So user can get also independence in that cases that they can select one or multiple research problem from here. And as before, it also go in the output or asset section that user also can delete later if they want or they don't like the research problem in the next stage. Then we also do the literature review for you. Like when you have the research idea and the research question, we also do the literature review from different sources. And for these things, we have our own large-scale vector database or independent system, you can say. It's called Work as Ask. There you can search your literature review, depends on your research question. And we also getting the bibliographic data from there or the citations because we need to cite or refer the literature review or to figure out the limitation of the existing domain, whatever you give the research idea, or the state of the art. So we also try to figure out in these things. And after the literature review, we know that we have these limitations, and we also know this is the state of the art. Now we are talking about the methodology section, because user need the methodology depends on these things. And at the beginning of the methodology section, we try to figure out the hypothesis, what will be the hypothesis specifically for these things. So it can be one hypothesis, it can be multiple hypotheses. So user can select here one or multiple hypotheses. Even user don't like it, user can ask or regenerate or give more hints or more things to generate more in-depth hypothesis if they want. Then as before, user can select it and it can be delayed or updated later also. And after that, we generate a full methodology section, depends on the state of the art and also the limitation that we know from the literature review section. And user can add it, remove it, depends on, user can interact independently with the system. And this specific part is designed for the computer science people or the computational things that if we need the implementations, or we need the code. Yeah, we have the idea, method, and something, and it's not proof by something. So in the implementation section, this multi-agent system can write the code, and they can compile it, they can run it, and they can figure out that is there any error or not. If they find any error, then until a number of iterations, it can go again, solve it, and do this type of things. And end of the day, they try to figure out that what is the best optimized code for this hypothesis and this idea. Then in the result section part, depends on the experiment, method, and everything, we try to figure out what will be the result section. In the result section, it also incorporates with the different data set. It will write that which data set it uses. It can be different sources like Hugging Face, it can use the Kaggle, it can use the GitHub, even your independent data set if you provide. So it will write the result section and you also give you the description in the data set and some other things that you use in the experiment part. then from the experiment, we also analyze the results. And this analysis is not only for the code it generated. Yeah, it also analyzes for the data set. It also analyzes for the error and why it getting error in the first iteration and what is the problem of this type of thing. So it also gives you a full analysis part, and user can select or user can delete. Even user don't like it, they can rerun it and they can use it in their own way. And after the analysis part, if you want, you can select or you can write it. You can ask the multi-agent system, okay, I like your idea and I interact with you in multiple stages, and now I need these things as a documented way. And what is the documented way for us? We ask them to write a paper for us or something, depends on these things. And it can give you the paper in the LaTeX, it can give you paper in the Word, and even it can give you paper in the PDF, depends on whatever you want. And if you want, you can also select that, yeah, I don't like your research question part, so I don't need it in the paper, or I don't need it in the documentation section. So it can remove that part. User can select it, or user can remove it in some way. And after that, when you have this paper or documentation things, we have a reviewer board. You can say multi-agent reviewer board, where this agentic system can review this documentation. Is it correct or is it not correct? Or is there any error or not error? In some way, it also tries to detect is there any hallucination of these things or not. It will also compare the state of the art and also the limitation and also the experimental things. Because if it is gives something that, yeah, human can live in outside in the world, or you can say human live in the sun, it's not true. It's hallucination in some way. So we can handle it also in these things. And after that, if you want to publish this paper, and some way this is not ethically correct if it's fully AI generated. Yeah, so that's why we are also incorporated with the human, we verify it and we try to do it. And we can also recommend you which venue you try to publish it. So we can also recommend you the journal, conference, and other part also. And yeah, in the post-publication phase, we are also doing these things. What is the current research we are doing now in this direction? We are currently working with the deep hypothesis and deep research question generation. You can say me that, yeah, I can use the ChatGPT, or I can use the DeepSeek, or I can use my own LLM or own chatbot. I can ask them, they can give me the answer of the research question and hypothesis. Then why I use it? We are also working something called deep hypothesis and deep research question generation. And in that part, we already submit some papers or some experiment and results that, yeah, we use some, as example, some Monte Carlo tree with LLM, the neurosymbolic approach, as I like to work, and try to figure out the deep hypothesis or research question from there. We are also working with the deep method and deep implementation section. And this code is fully written by AI. And human can interact it, but it's written by AI, error solved by AI or this system, and also try to do the visualization part with VLLM and some other things. And we are also working that how we can work these things with the independent data set, as the knowledge graph. You have a company and you have the knowledge graph, or you have a research organization, you have the knowledge graph. You have your own data. You don't want to use the independent data. So how can you incorporate with these things? How can we collaborate with these things? So we are also working in that part. We are also working with the deep result and analysis section try to figure out how can we improve the accuracy, what will be the error, and how we solve it and how to do it. And we are also currently working to introduce the first version of the scientific reasoning model. We know the reasoning model, but these models are not scientifically reasoning for a specific task. As an example, solve the protein folding things, or solve the chemical bonding, solve something in the microconductor, or some other industry. We are also trying to develop our first version of the scientific reasoning models that can help to solve the scientific things. And we are fully open source. Yeah, that's our first things. We are fully open source for every part. And currently, our AI assistant can use different tools like Crossref, Semantic Scholar, ORCID, PubMed, Archive, and different sources for its knowledge source. Even you can use your data set and some other things. And as I said, it's fully configurable. You can use it. You can delete it or whatever you want to do. You can configure your tool, assistant, asset, and all of the things. Like this, you can also configurable these things. Yeah, I'm a little bit time out there. Okay, just one more slide because the main reason or main concern from a lot of audience we get is the ethical consideration. Like, is it really ethical that you do it or not? So, firstly, we are not saying that, yeah, you write the paper with ChatGPT or our AI assistant and just publish it. No, it's not ethically correct. Still now, yeah, because if you go in the conference site and you see they have their own AI using things. And we believe the transparency. How you generate it, how you do it, we give you the full documentation. It's fully transparent. You can also getting like the biasness. We try to avoid the biasness and all type of things there. And we try to directly communicate with the community, with different conference, that is it really useful that you can do it? Because we know in this domain, some people are already try to use it with the ICLR. They have the full AI written paper and submit it in the ICLR in the workshop, and they say it's accepted and in the workshop level. So in the current benchmark is AI written paper is accepted in the workshop level, but yeah, it's already like removed from the workshop. And this is our publication, and you can find the data, code, everything there. And yeah, any question? Sorry for taking a long time. Yeah.
Thank you, Golam. We have time for one question. There's one. Yes. Oh, it will be alone.
Okay, thank you very much. That's a nice project. But how would you compare your solution to commercial solutions like Scopus AI or Elicit, which has almost the same features?
Yeah. So, like the things you said, the Scopus AI is not, as far as I know, is the full like human AI written the solution or something. They will provide you recommendation. But we are not provide you recommendation. We provide you some domain or some solution for a specific problem. And for the current, like the state of the art, as far as I know, the state of the art is the people are write or use this type of things and submit it in some conference with like that must be talk with the the committee of the conference, and they say that is this paper getting really accepted or not. Another good example can be like DeepMind. They already solve it with the protein folding. So you can use this type of system for solve the unsolved problem for the society. So that's the goal basically here.
So did you apply some kind of benchmark of your tool with the other tools?
Yeah.
One of the applications or the publications, I didn't recognize them. Maybe you can switch back to them. It was too short visible. Ah, that's it. That's nice. Another question is?
No, we will only have time for one.
Only one?
Can you?
So I have return and come back. Okay.
Yeah, thank you.
Our next speaker is Alexander Bigel. He is from a project Tentris. And I was made aware of Tentris a couple of years ago. In the year 2003, it was dropped in our chat and someone suggested, try to use Tentris. And on the next day, one user already submitted his post and said, Tentris is amazing. So I'm quite eager to see what happened. And today we have a CEO of Tentris here. So Alexander Bigel, go.
Thank you very much for the warm opening. I just need to find the right. Well, we lose a bit, but I guess. Give me 1 minute. I'll. That looks better. Okay. I guess we see everything now. Okay, great. Now I'm set up. Yeah, again, thank you for the warm opening. I want to present you today how you can scale up your RDF game and wait less and query more. Who are we at Tentris? Maybe I start with who am I, as I'm the one of us who's standing here today before you. I did my bachelor and master degrees in computer science and always liked especially the database side of knowledge graphs and knowledge graphs in particular. That started in the bachelor thesis, then went on in the master thesis, and even continued then into my PhD. The others are Toby, our business guy, Nikos, who is also doing research, especially on efficient query processing for graph databases, and probably most of you know Axel, who's a data science professor at University of Paderborn, and before was also here in Leipzig. So we had a look at RDF in the recent years, and there's probably a lot of things where people would say, well, that was holding it back, but from the graph database point of view, what was holding it back in the last 20 years? We think it was poor read and query performance, especially at scale, poor write performance, so it's unsuitable for data-intensive use cases, like if you have a web shop with a lot of customers producing transactions in parallel, and it has a steep learning curve. So semantic technologies and also the tools that are related to it are sometimes a bit hard to use, and we see their potential that's being underutilized. Tentris sets out to solve at least some of these problems. The first is the efficient query. And I think that's the core of where we innovate. We don't use binary joins, as you probably all, or at least the computer science degree people among you learned them in your bachelors anymore, but we use worst case optimal joins. And these have been proven to be asymptotically faster than binary joins, and that, we'll see that in a moment, also translates to shorter runtimes in real-life queries, especially analytical queries. The next part is the efficient indexing. So we think it's important that you support fast queries, but also support fast updates, and that shouldn't let your storage footprint explode. And that's why we also, that's our second core innovation, the hypertry, which is kind of an index structure that brings together all the indices you might need and compresses them some kind. I wouldn't go into details here now. There's a research paper on that for anybody who's interested to go deeper there. And last but not least, we think a graph database should be very easy to use. It should be standard compliant, and it should have a clear interface. That's kind of our first small contribution of making the semantic web stack easier to use. Maybe one very specific part, you never need to optimize indices. With Tentris, we have all you could need already there compressed in the hypertry. Yeah, for benchmarks, I've promised them, here they are. We've used the BSBM benchmark, which is a business intelligence use case, so you have analytical queries, and we compared here against a disk-based competitor and an in-memory competitor. You see on the left side, there are certain query templates, 1 to 8, and on the right side you see the average over the results from the left. And I wasn't expecting that, I'm very sorry. Well, and as a baseline, we take the speed of the disk-based competitor, and then in red you see the in-memory competitor, and in blue is Tentris, our system. And as you can see, our system is often as fast or faster than the in-memory competitor, and there are queries where it's substantially faster. So for example, query template 2, that's 150 times faster than the other systems there. Yeah, and I also prepared a very short demo. So we have here the typical one that's used for comparison, a Fuseki instance that has this BSBM dataset loaded. And we have Tentris. Here we start Tentris with the command for Tentris, say where the configuration lies. That just says where to store the data, but very small configuration, and then serve to start the endpoint. And endpoint is started up. Can close the terminal again. And yeah, I brought you here one of the BSBM queries. This one looks at this product 4721 and searches for other products that share features with it, and sorts the results by the products that share the most features with this 4721. And yeah, we can run it here on Fuseki. Takes a while. In the meantime, let's go over to Tentris. We have here the exact same query and can run it. And as you see, the button already stopped, so it took 0.5 seconds. And going back to Fuseki, it's still running, but I think it's only about 20 to 30 seconds, so you can shortly wait. Ah, there, it finished. Yeah, it was about 27 to 28 seconds. Great, so thank you for your attention, and if you're also interested to try out Tentris, we are about to release a beta, so you can pre-register. Thank you.
Well, thank you for your presentation. Are there any questions?
I think you need to go to the microphone.
What do you support from Sparkle 1.1?
Sparkle 1.1 support will be complete with the beta, but except for entailment regimes. They are not in there yet.
Okay.
So with all the graph store and yeah, what there is, like this whole specification.
So is there another question from the audience? No, it's not. Thank you. And let's move on to our next speaker. Our next speaker comes directly from eccenca, and he's the principal of data science. It's Edgar Marx. I guess almost everybody knows him here around. And he will tell us something about leveraging agentic data flows with large language models.
If it shows up.
Shows up?
It shows up. Okay. Yep.
Okay. So, round of applause.
Thank you very much. So when I was preparing this presentation, I don't know. I like to walk. So I'll try to keep here. There is a microphone, it'll be better. Anyways, when I was when I was preparing this presentation, I wanted to do something more active, like Alexander did. So I'll try to. Hi. Okay. So I try to do the same. And just a testimony, we are using Tetris also in eccenca. We have a research project together, and we are quite happy with it. So just 2 words of support. It's really great. Yeah, so let's start. I think this is slide Marcel today earlier already shown. So eccenca, basically we are based, we're distributed all over Europe. We used to have some people outside Europe as well. I'm not sure if still in Africa too, because we have, Neves is confirming here, yes. In Nigeria too, right? We still have, okay. So yeah, we are globalization, you know. Yeah, and the outline of the outlook of this talk today will be as follows. I'm just to cover a little bit something that you already know, the data tasks that all of you, or most of you, spend your time on, and we have maybe, I've seen also some people that manage people that are working on these tasks. Then I go dive a little bit into the motivation of this talk, showcase something to you guys, and hopefully we're gonna have some time for questions. So let's start. I think already everybody knows this data life cycle. It's called linked data life cycle, but I think we can generalize for diverse data tasks. But what I want to call your attention here is the last box there, which is the data analysis. And as you can see, you have to go to all those steps to then be able to perform some analysis on this data or to use. So the data is useful for something of machine learning or fine-tuning your machine learning models or to perform some analytics. Okay, so that goes to the 80-20% rule, which says that 80% of your time you're going to be working on the data, and just 20% of the time you spend on this organization, you're going to be actually getting some benefit of this data and the data streams tasks. And these are due to a lot of things, handling missing data, removing duplicate entries, correcting data types, and so on. I think a lot of you are already familiar with that, so I'll skip this slide also. So we are working on this a lot in eccenca. We have many clients, so we're thinking how we can use this new, I would say, generation of machine learning models, which is all based on transformers and so on, to leverage, to facilitate this data streaming tasks, as I explained to you before, which consume 80%. So if you are having a team and dealing with budget, you know that we're spending a lot of money on these tasks. And here I bring to you some very conflicting, I would say, views on especially large language models. And we have the startup guys that say, well, AGI is coming, and it's always coming. And we have also Elon Musk. This is actually from 2015 when he was saying that driverless cars were coming, and still not there. And we have my favorite guy, my hero, which is Yann LeCun, which I think is the most realistic. And he clearly states, we are not there, we are not even close to be there. And basically, if you want to be there, you need still to go one step forward on the architecture which currently these companies are using. And so if you look at the large language model evolution, one thing that we can highlight here is that across the years, there are a lot of companies working on them, and I will call them foundational models. Why foundational models? Because they are pre-training these large language models on massive data sets. They are getting smarter. And this is very good for small and medium enterprise because it consumes a lot of resources. I think at the end, I think you're going to see even governments step in and also start to train large language models and release for small and medium enterprise and so on, as so research organizations. But what we want to call your attention here is graphics actually from 2024, where you can see Llama 13 billion, Alpaca and Vicuña, and you can see the difference here on the performance, and ChatGPT, which is approximately 100 billion parameters. And why I want to call your attention here is that you can see Alpaca and Vicuña is basically fine-tuned on the Llama 13 billion parameters. So what you can see here is that you get a foundational model, like 13 billion parameters, if you fine-tune, you can actually almost double the accuracy of these large language models, why I'm showing you this, because I think this is the future. This is a feature that we see the companies going, working on fine-tuning models. So there are two ways to actually work on these foundational models. One is RAG. And if you are from the research, if you have some research background, or even if you don't have, you heard already, I think, probably about this famous papers from Google, which is attention is all we need. And more or less what RAG does, and actually the RAG approach is also from Meta, which is the same creator of Llama, large language models. What RAG does, it activates some part of the large language model that is related actually with the context that you are adding. And the nice thing is that it also uses the context that you are adding at runtime. So you don't need to fine-tune the large language models. And this is really easy approach to implement. I think most of you already have implemented that. But there are of course, some problems on that. The other way is, but what we think here in Eccenca, now coming back to our product, is that what you see, how you see this going, is that people are going to work in the knowledge graph, add knowledge to these knowledge graphs. Of course, here can be text as well, but now in the context of Eccenca is knowledge graph. And you're going to fine-tune these models and also receive feedback from these models to also add knowledge to the knowledge graph. So this is the whole cycle. And we've been working in that direction. So here what you can see, what you've seen the first speaker, that's why I want to do more dynamic. I wanted to show the product. So here what you see is that our platform where is everything drag and drop. This is agentic lifting. I'm going to go just a minute. Okay, maybe the login is missing here. Yeah. So let's go one step back and show how things are done currently. So it's basically we have the transformation here. It's a very simple example. Actually, there is a tutorial in Okay. Okay. I think there is. I'm not sure. Oh, okay. Sorry for that. Yeah, I don't know. Okay. I swear that I tried this before and was working. Wait a minute. Okay. So we can, this is usually the way that it's going, and I'm just going to dive a little bit here. To the mapping editor, and you can see that there is a lot of things to be set up here, which field, which type of field, and so on. And then you have to configure also the URI, which you have some kind of workflow here, you have to glue things together, and et cetera, et cetera. And as the data complexity grows, maybe you have fields together and you have to separate them and so on. You all deal with this kind of problems. And so we go from this to something like this, which we now have a workflow that you can configure something like that. And you just have to say what it has to do, and that's it. And actually, this is already available in corporate memory. You can just drag and drop, and you can have the agentic service lifting. So this is just an idea. Of course, there are problems here that you have to overcome, but you can also, for instance, do rag. You can create embeddings, and yeah, these are actually I'm using just a minute. Execute instructions, but you can also use a rag application, which I will not show up here today. Yep. Yeah, so let's back to the presentation. I know that you're going to have a lot of questions. If you are interested, you can already access the eccenca.mi. You have your instance. You can try out. And I'm open for questions. Thank you very much. Yeah, that's one thing that I say that there are a lot of things actually that you can integrate on. So as you've seen the workflow with creating with the agentic, actually what you could have is another box there, which is something check with shackle shape, that you then maybe give a feedback to another agent, hey, fix that to that. And then maybe go feedback loop to the same box for the check with the shackle shape. And then if that's okay, then you go and then store in the database. Here I wanted actually just to show a very simple example. And we are very excited what our clients are going to build with that. And we have also Sebastian Simonide here, which is doing something also really interesting with a lot of clients. So every time in the office, very excited, someone has some idea, new idea, how to integrate that in the workflow and facilitate these transformations, really something, yeah.
Yeah, no further questions? Oh, no.
Okay, we have a chat. Questions, okay.
Yeah, Vishwa from the stream asked that on the slide A you showed some scores for the fine-tuned model versus the original model, Llama 3. So the improvement it achieved was for a specific domain, or was it like for a general area?
That is something that is also related with my talk. All these models, what you can say about these models that no model will be good in everything. So this is our vision, and companies are going to start to fine-tune these models using the knowledge graph or some other data sources. Actually, didn't have time here, but you can integrate a sensor corporate memory with different graph stores and also with a relation database. So it's quite comprehensive too. It's not just about knowledge graph. And so in this case here was a specific task, was an question answering task. And yes, they could achieve what 100 billion model that people will spend something like $300 billion. And I think in this case, in a particular case of Vincunha, they spent $40,000 in the hardware, and was 3 people basically that did this job. So yeah, it's quite something. It's quite some achievement.
So now the last speaker for today's for this session is Lars Peter Meyer, one dear colleague of mine, and also Johannes Frey, and they will tell us something about the current capabilities of LLMs. So, Lars Peter, Johannes, the stage is yours.
Maybe Johannes wants a micro. Okay, thank you for the introduction, Carol. Yeah, we want to give a short overview on our research on the current capabilities, knowledge graph related of the LLMs. Let's imagine you want to find out more about this big black box of the knowledge of the large language models, and maybe as a good researcher you would think, which question do we want to ask her? Maybe is Turtle or JSON AD input better? Which language model is actually the best to go for the text-to-Sparkle task? And then you would think of some kind of experiment. You would try to come up with a good input prompt, maybe containing some Sparkle or knowledge graphs, and then feed that into the large language model and look at the answers coming out of it. Try to evaluate it, try to come up with some kind of answer. This is actually done quite a lot of times. We have been doing that early on 2023, and it is still my most cited paper, and I'm quite happy with that. And many, many more papers are following in this kind of way. But the problem is the large language models are non-deterministically working, so you normally have to repeat your experiment quite a couple of times, and you have to do it again and again for each new question, and especially for each new language model, and they're coming up quite a lot at the moment. So we thought this way is not scaling. We need some automation there. And back 23, we started the AMKG Bench framework for this kind of automated evaluation, where you mainly interact with the framework, and then the framework handles all this, iterates it quite a lot of times, and come up with logging, nice reports, a nice analysis, helps you with the analysis of the results. And to give you a little bit more details on this framework, you mainly configure which models you're interested in, which tasks you're interested in, and then the framework handles this iteration stuff, and we just created a big data set which covers 40 LLMs. We had configured to use 7 tasks with plus several variations are there, and each combination was repeated for 20 to 50 iterations to be on the safe side for this non-deterministic answer problem. And the framework mainly helps you with the automatic execution. It's modular. You can just config it, and the logging is in deep managed. You can even repeat your experiments later on with the given answers earlier, and it helps you a lot with the analysis. And now I hand over to Johannes for some examples of the results we came up with this framework.
Yeah, thank you very much. One major capability, especially when we want to deal with knowledge graphs and all linked data related assets, we found is like a basic skill should be handling RDF serialization formats. And back in 2023, when we started with the first version of LLM KG-Bench, we wrote a paper about how well turtle could be handled by LLMs, because we found it like one of the most basic and useful and prominent serialization formats, which are also used, for example, in the Sparkle query language, or which can be used in RML mappings as a serialization. So it's quite common in linked data technologies. And as a little recap, one of the results, so we looked at many different tasks, how these LLMs can deal with it when it comes to reading, analyzing, and serializing. And this is we found this particularly useful. It's about how well can they fix single errors or very simple syntactic errors in these turtle syntax. And when we look at back then, 2023, we can see that some commercial leading models at that time performed well, but other ones, sometimes even newer iterations of those models, were performing worse. And the good thing is, when we have a look nowadays, the picture looks much better already. So the white circles you can see represent the average of all those different iterations. And the F measure of how many incorrect triples were passed, were still remaining. And when you look at those, you can see that all the leading commercial models are almost perfect nowadays. And the little ones, or the less ones that are still left, are open models. And together with a colleague from DFKI, we analyzed these open source models that you sometimes can even run on your commodity hardware when you have like 1 or 2 or 3 billion parameters in size. We analyzed this, how well they can perform depending on the size. And as a kind of rule of thumb, we found out in this paper that, for example, with the Llama 70 billion models, you're always good to go. You're almost at the F measure of 1, but when it comes to lower numbers, it's still not sufficient at the moment. But as a maybe take-home message, if you're looking for a model that's performing well and doesn't consume much resources, you might want to have a look at Qwen 2.57 billion, which is one of the best cost performance ratios here we found. If you want to have a look at the paper, there's much more details on different tasks, so you can maybe get some impressions there which kind of model might suit for a specific use case or problem you're facing with. And when it comes, so this was what I showed was about the turtle representation language, but I think most of you probably know that a lot of vendors fine-tune their models or train their models in order to support the JSON notation especially well. So we also had a little look whether it makes a difference whether you use JSON LD, which is a representation, versus turtle. And when you look at the the leading LLM commercial models, again, you can see that usually there's not much of a difference, so they handle both very well. But when it comes to the smaller models, we found that for some tasks, JSON LD was better, and for some tasks, especially when it comes to question answering and Sparkle-related stuff, turtle was the better representation.
Okay, And to come back to Spark capabilities, we checked that as well with a couple of tasks. And sometimes you don't want to have this big box plots, but we even support this capability plots, we name them. You see here on the right-hand side, where we defined a couple of different capabilities, Spark-related, and we can see here, for example, for the Claude 3.5 Sonnet model, it performs quite well. The black solid line is quite in the outer, near to the outer ring. The blue area indicating the standard deviation is quite good as well. It's definitely better than the Quen 2.5 billion 2.5 model on the right-hand side, but here we have shown only one with 1.5 billion, and even this model, small model, is performing quite good with when coming to the syntax of the Sparkle. So it was good correcting the syntax or coming at least with syntactically correct Sparkle queries for our use cases. But the main problem was we have this nice figures here. Last week we were presenting at the LSWT with the Texas Sparkle Challenge as well, organized by a couple of persons. Among them were Edgar, Sebi, and Markus here in the room. And 8 teams participated there. My impression was the best teams used proprietary models, most of them OpenAI with GPT, and most of them used an agentic approach. But the best approach was 45 to 55% F measure. We were happy, we have done it like this, and we got a good results, and the parts with DBpedia, English DBpedia, and the corporate graph. And on the right-hand side, I've shown this diagram, and I'm checking the time. Okay, I have a little bit more time to go into more details. There, with the agentic approach, we handled the large language model, the capability to interact directly with the knowledge graph. We let it iterate over the question. We gave it a question and then told it, you can search for knowledge graph entities. What would we need? Please search for it. You can then test your Sparkle query. You can get more details, and this way iterate over the problem up to 15 times and try to come up with a good answer. And actually, the result was quite good, but in my opinion, 50% F measure is probably not yet good enough, and we're looking for next year continuing this. So, let's come to the conclusion slide. We have this open benchmark framework, open source available, and looking forward to continue this work. We have now shown you the main take-home message with RDF syntax. The work is quite easy apparently with the large language models nowadays. When you have to choose between JSON-LD and Turtle, probably you should evaluate first, okay? But if you don't want to do that, maybe you want to start with JSON-LD. Sparkle, it depends a little bit. At least syntax is okay. Sometimes you're good with it. Sometimes you still need more to go there. And yeah, I'm open for questions.
Let's have one question. Anybody is eager to ask? Please step up to the microphone.
Maybe I will take the time and mention, of course, this was not the work from only Johannes and me, but there were several co-authors that helped us getting to this state now.
I have one short one. Everybody ask one.
how are you making sure that the new models are not trained on your test data?
Thank you for this question. Yeah, I forgot to mention that we now started encrypting our task data, so it is not that easy to read anymore for the large language models. But of course, we want to have open data, so we put the password near to the encrypted data sets.
Yeah. So thank you Lars Peter. Thank you, Johannes. Okay, so now the session comes to an end. I want to remind you that lunch is now serving, and generally, no? The student session. There's no lunch? There's always lunch. What are you doing? So now we have the student session. I welcome Professor Michael Martin to the stage.
So please don't leave the room. Thank you, Carol, for this nice session moderation we had. Between you and the lunch, we have still half an hour left. I think it's okay. Yeah, in the last hour we had 4 talks about 4 very nice projects, and in the next half an hour we have 3-4 talks about 26 projects, and we will do this now. And it's a pleasure for me to introduce it for the students. From my point of view, it's always a really, really good idea to involve students to conferences, to work with students together. These are our future experts. We need them, and it would be really nice to get some information about the student courses which were taking place in the last half year, 1 year. And next really, really cool and important thing is that it's not a local action. We have organized together with 4 universities, high schools, with 4 professors, this session, and one is coming from Sachsen-Anhalt, Saxony-Anhalt, one from Brandenburg, one from Saxony, and one from, geography, it's Lower Saxony, or? Hamburg? Lower Saxony, right. Okay, almost. Right, so, and I would say, so in the last years, we organized it like this, that each of the students had to introduce their projects. This year we do it differently, so the professors are presenting the courses and their contents, and if you want, you can as well pitch for your students. So because outside there are these student poster booths, and you are able to vote until 3:30, as I remember. There are 2 dots on your tickets. You can pick them up and put them on the posters, and vote for the best design and the best content poster. Green is for content, red for design, as I remember. And I would say let's start directly, and I would say we start with Lisa Weniger from Merseburg, from Sachsen-Anhalt, and Lisa.
Yes, hello. Thank you, Micha, for the introduction. Today I'm going to present the student posters from Hochschule Merseburg, also called HOME, because of Hochschule Merseburg, University of Applied Sciences. We approximately have 3,000 students, 28 degree programs, and today I have brought 5 projects from 2 degree courses, Bachelor of Engineering, Technical Information Design, and Master of Arts, Information Design and Media Management. So the focus of these degree programs is design, technical communication, but also computer science, also a little bit of data. Students typically go into e-learning, into software project management tasks, also technical documentation. And I've brought 5 projects from bachelor and master. The first project was worked on during the last winter semester in the course Data Analysis and Artificial Intelligence, and the task was to collect a data set. In this case, the students collected data on video games from Wikidata, so they collected data for about more than 6,000 video games and conducted a data analysis, made general inquiries concerning the genre, the types of video games present in Wikidata and also on the platforms, performed Sparkle queries, transformed it, and made a nice display on the poster. And all of them worked pretty much on themselves, and it turned out quite well. And they also published it on GitHub. So Games and Graphs, Video Games in Wikidata is the first project by Smilla Hill and Talena Thielke. Have a look at it. So then we have the second 2 projects. They also were worked on during the last winter semester in the course Usability Engineering. And for that, we worked together with the National Center for Environment and Nature Conservation Information, Umweltinfo. This is a new center, was founded 2 or 3 years ago in Merseburg. So we are close together, we work together, and they provide a search engine for data sets on the environment. I think in Germany it's probably the biggest search engine for data sets, for open data sets, with currently more than 1 million data sets. And during our course, the students tried to come up with new interfaces for dataset recommendations. So tested them out, also evaluated them, and one of these projects was by Valeria Safonova. She compared different recommendation approaches, dense retrieval and sparse retrieval, compared BM25 algorithm with an embedding-based approach, and then also conducted a small user study where she asked participants which recommendations for data sets do you prefer. Yeah? And she found out that both recommendation approaches fared quite equally, with a slight preference for the BM25 method. So there was a slight preference for that, and maybe this can also be combined in the future. So there was a small prototype she developed with Streamlit as a Streamlit app. The second project was an interface that was developed by Julia Heinzel. She developed a user-friendly map to display dataset recommendations. So Umwelt.info ships their datasets in the catalog with bounding boxes, with geodata. So Ms. Heinzel made use of that and displayed it nicely on a map so that users could have a closer look. Yeah, where are my interesting datasets located? So also deployed it on an app and evaluated the interface. These were the bachelor projects. Then we also had 2 master projects in this year's course, this summer semester term, second semester, data and knowledge management, where we talked about different levels of data openness and also how to make use of structured data in the age of AI. And this project was developed by Margareta Frauenholz and Lucia Aida Yamas-Kirchhoff. They had a look at, made a data collection on abortions in Germany and had a look at different aspects First of all, on rights, on the legal situation, and also on medical care. Had a look how many gynecologists do abortions. It's only 6% in Germany they do that. And even in Saxony, only, there are slightly more, 9% do abortions, but only 2% of these gynecologists, they counted that on the websites, only 2% of these gynecologists make an advertisement on their websites. They talk about it on their websites, so women can't find where abortions can be done, and they counted that. They made quite a comprehensive, extensive research for that, and also, I think, presented it nicely here on a dashboard, on a Grafana dashboard, collected all this data, found good representations for it, and brought it on a Grafana dashboard. This was the first master project. The second, but not least, master project was done by Hanna Leonie Merks. She developed a patient service LLM agent for the rare diseases platform Semantic Care. She made it possible with this LLM agent to answer FAQ questions that were typically posed on the rare diseases platform, and also made it possible for users to research symptoms of rare diseases via the agent. The agent makes use of function calling and calls a public API or FanaNet to retrieve information on rare diseases. So take a look at these projects. They're outside. Come talk to us and vote for us. Thank you very much.
Thank you, Lisa, for these very fast pitches, and thank you to the students as well for the really nice projects. On my list, the next speaker is Vera Meister from Brandenburg. And die Präsentation.
Ist das?
Oh, okay. Thank you very much. First, I want to make one thing clear. High school is a false friend. Hochschule in English is University of Applied Sciences, even if it's technical. Ja, Technische Hochschule. Okay, my name is Vera Meister. I'm Professor for Information Systems at University of Applied Sciences in Brandenburg-Havel. We teach knowledge engineering or knowledge graph technologies in compulsory master courses in the second and in the third semester. I want to give a short introduction to that courses. This is a beautiful view of our university. We are on a former military barrack campus in the not the outskirts, but only not in the center of Brandenburg-Havel. And we have some historical buildings and some modern buildings, which you can't see on this slide. We have around about 2,500 students at the moment in 3 departments. I'm working in the department for business administration and management in the study program information systems. Here you can, this was too fast. Here you can see the more or less the content of these 2 courses. The first is called Enterprise Knowledge Engineering, and here we have a lot of, let's not call it theoretical stuff, but a lot of technological stuff, starting with basic concepts and all the technologies you have to know for building knowledge graphs. 60% is the introduction and the teaching, and 40% round about the project. And the second course is Enterprise Knowledge Graph Implementation. Here you can see that the project part is much bigger, and the theoretical part is divided between me and my colleague, Professor Felix Sasaki, who in some years ago worked at our university, but now is Knowledge Graph Director at SAP Innovation, something like this, campus or center, innovation center in Potsdam. I'm focusing on Shackle and related use cases, and my colleague has taught prompt engineering for knowledge engineering. He comes up with practical problems from his professional sphere, which he is interested in that students address them, and also afterwards it not for all students, but for some, it comes to master projects, which in cooperation with SAP. In the last year, we had 6 students working with us in these courses. 4 of them are here, Viam Faradi, Ayush Kamwar, Runze Zhang, and Lukas Teutenberg. 2 of them couldn't come because of health issues. And the students are really free to choose their project topics. And Viam addressed a topic which is very recent for her, because she is now starting her master thesis, and she was she had problems to find all the information on different websites and different knowledge sources, and therefore she thought how it could be managed with the help of a knowledge graph to put this all together and to make it better addressable. Ayush Kumar is a fan of Swiss knife aspects or Swiss knife concepts, and therefore he built a multi-tool for dealing with TTL data. And Runze and Lukas, they tried to look at how LLMs can help to bring textual data to shackle shapes, and also analyze to what quality or what is the quality of the results. Not as deep as we heard from colleagues from in the session before, but nevertheless an interesting starting point. That's all, I think. Yes, thank you.
Thank you, Vera. So you see, we come from open data to knowledge graphs, and I made a further mistake in my introduction because the next speaker is not from Hamburg. It's from he is from Leuphana University in Lüneburg. And yeah, it was. Yeah. So and. Because professors sometimes have not enough time, so they are not attending the conference, but the students can introduce themselves as well. So, and yeah, you're very welcome.
Thank you for that introduction. My name is Kai. I'm a research associate in Ricardo Uzbek's group, who Martin just said couldn't be here today, but sends, of course, warm greetings to everyone. Just a little bit about Leuphana University. With our beautiful main building that you can see here, is a university in Lüneburg, which is in Lower Saxony, that describes itself as a humanistic university, so places the belief that everyone has the freedom to form its own character in its education. Is importantly a sustainable university, or trying to head in that direction, both in research, in education, and its operations, and a entrepreneurial university trying to get research into action. And it's also a young university that over the last 15 years has significantly worked on its research output, which we are very proud of, reflecting in some of the major university rankings for the young university rankings, where we place 5th in Germany and best in northern Germany. But that's enough education for Leuphana itself. So I am part of the AIX research group for artificial intelligence and explainability, led by Professor Ricardo Uzbek. I haven't put it on the slides here, but also a quick mention. We're engaged in by now 9 different courses in both bachelor's and master's in information systems, in the bachelor, in management and data science in the master's, and very freshly starting next semester also in a minor in artificial intelligence that allows any student at any course program at the university to gain insights into new developments and also critical reflection about AI. So what we are doing with is a whole cycle of hybrid AI and its applications. 2 main focus areas are the knowledge extraction and representation, so more towards building knowledge graphs that we are talking a lot about here. One focal point is event extraction and localization, always with an aim to enhance the resilience of supply chains and also societies in general. Extracting events, localizing them, transferring them into knowledge graphs, and on the lower left-hand side, some work that I have started in my master's thesis and continuing now, that is also on a poster outside for using spatial reasoning over the geo-entities to identify the location of natural disasters. Some other aspect that we're doing a lot is question answering over knowledge graphs. I'm probably not telling anything new here, but a very brief explanatory example. If you ask who's the ex-husband of the daughter of John Voight, that slide was made before John Voight was appointed by the Trump administration as a Hollywood special ambassador. But you would probably first, we use large language models and investigate how they can form Sparkle queries to address this question. So you would start with the entity of John Voight, who has a child which needs to be of the gender female to fit the daughter, and then from there, which should return Anjali, you go to Angelina, to the ex-husband of Note, and hopefully find Brad Pitt. So doing those kind of, after we built the knowledge graphs, question answering systems to retrieve factual information. This is just a very brief overview, of course, of what we're doing. If you have any questions, are interested, please feel free to reach out. I, as I said, also have a poster about some recent work that I have done outside, and if you have any questions on that, on georelating, please just drop by. Thank you.
Thank you, Kai. Greetings to Ricardo. And yeah, go then afterwards to the booths and ask the people directly. And now we come to the last picture. Is it right? Yeah, Thomas Richard from University of Applied Sciences here in Leipzig, HTWK. And you both will speak about, or it's only you, Paulo? You both, okay. So then.
So thank you very much for let especially the students present their posters here at the Leipzig Semantic Web Day. So I just want to say a few words to the University of Applied Science, Leipzig University of Applied Science, mostly in German. People from Leipzig know us as Hochschule für Technik, Wirtschaft und Kultur Leipzig. We are one of the biggest University of Applied Science in Germany with 6,500 students. We are located quite close here at the Karl-Liebknecht-Straße, and the part is called Konnewitz. And we are divided into 6 faculties, and the students here presenting are from the Faculty of Computer Science and Media. That's quite interesting, comparing to the other presentation of the other universities here. So you see we have quite a lot of courses in this faculty. So we have a wide range, starting from librarian science to printing and packaging science. And an important part is, of course, then computer science and media informatics. Both are dealing with data management. Maybe the informatics in the study course is more deeper into back-end development, and media informatics more into front-end development. Both group of students attending together this course that we are presenting here is the Semantic Web course in the 5th semester of the bachelor degree in informatics and media informatics. So I want to hand over to Paulo De Carmo. Paulo De Carmo is a PhD student. He's doing the PhD together with the University of Hanover. You already have seen some presentation from Open Research Knowledge Graph. He is here since 3 years so far. We started with an internship during the master thesis, and then now he's working on the PhD here. And one part of the PhD is, of course, also taking over lectures and getting experience in teaching. So I will hand over the microphone to Paulo.
Thanks, Professor Richard, for the introduction. So this semester, like he said, I am doing the lectures for the Semantic Web module. And a little bit different from the other students here is that this is a module for the summer semester, and we started in April and we're still ongoing. So there's still lectures, there's still seminars. Their projects are ongoing as well, as you're gonna see in the posters. And unlike also the other presentations. We have 15 posters from 26 students, so I cannot give a profound pitch on each one of them. So if you want to know more, you're going to have to go and talk to our future experts. So I'm going to just show a brief introduction and the titles, and then if you're curious on knowing what their projects are more about. So in short, all the projects are a full transformation pipeline following the linked data lifecycle. So all the students picked their data sets and they are doing the RDF transformations and going from hopefully to 5 stars in the end. So we have projects from a lot of recommendation style data sets, so from Amazon book reviews and user preferences. We have from the Twitch streaming website, so it's a live streaming website, so it has information about the users, which streamers they follow, and what's their overview of watching. We also have some news data sets here from the Microsoft News data, and it has information about what you click on each one. The Goodreads book review, which is another recommendation systems-based data set, where you have information about the readings, partners of the users of the platform. This is an interesting, more political style, which combines 2 data sets to try and create the relationship about urban violence and press freedom. The Steam games, which has information about the users and which types of games they try to understand. Spotify stream songs, which I'm sure everyone hears about. A lot of streaming services interested the students this module. This work with healthcare and services providers, which has information about when you go to a hospital and if the insurance covers it. From Internet Movie Database, so it's a whole semantification of the IMDb website. Netflix movies and TV shows, so it's information about some of what Netflix makes available of what the users do in the platform. We also have analysis about cybersecurity threats, so which types of attacks happened in the period of 2015 to 2024, how political bias influences the spread of misinformation in news as well. The anime recommendations, so it's just this platform that users go and say which anime they like and which type of information you can get, so you can ask interesting questions for it. And the phishing website, so another one related to cybersecurity threats and which websites are more accessible and other types of questions that can be asked. And finally, analysis of YouTube trends as well. So another more recommendation system related. So those are all of our posters, so a bunch of information that I couldn't possibly give to all of you, so please go and check out. Most of the students from the module are present here today, so you can go and ask questions directly to them. But know that the projects are not finished yet, so they are a little bit on a disadvantage here. So thank you.
Yeah, thank you very much as well. And yeah, from my point of view, all of these projects are super cool, and I would be very happy if you go to the booths and vote, speak with the people. It's a very important part. So, yeah, that's from my side. Thanks again as well to the speakers and the speakers from before the session. I already explained it, yeah. And yeah, you know what to do. I would say have a nice lunchtime, and yeah, thank you.
had an afternoon coffee and are not ready for a nap, because we have nice presentations coming up. My name is Noor Ramzi. I work at eccenca, and I would like to welcome you to session number 3 for today. We will talk about knowledge graph use cases in the industry and in the administration domains. And first up, I would like to welcome Marcia Ferreira. She works at GraphWise, and she will talk to us today about RAG, so Retrieval Augmented Generation, and how we can use knowledge graph to support that. Welcome, Marcia.
Let's just test this. Okay, yeah, welcome everyone, and thanks a lot for the nice introduction. We also want to thank our partner, eccenca, for the nice invitation. Being here today, the week has been very interesting and great. We also have a stand outside, so if you would like to have a chat, we're available. So yeah, so I'm Marcia. I'm coming from GraphWise, and GraphWise is a company that just is the result of a merger between Ontotext and PoolParty and Semantic Web company. These are the vendors that sell GraphDB and PoolParty. So I would like to start first with the obvious. Graphs are everywhere, and it's 2025. Most companies are at different stages of data maturity. However, there are still a lot of challenges in connecting the dots, and each company is in their own journey to achieve that. So how do we actually connect the dots? That's through graph technologies. But don't take it from me. Most 100 Fortune companies use knowledge graphs in the background. Some notable examples are Google, Facebook, and Netflix. So how do we come from having a graph to a knowledge graph, to something more meaningful and more useful? We can start with a simple example or a plain graph, where in this example we have 2 brands of shoes, Ronverse and Bike, and they are sneakers and running shoes. So what you have here is a very plain graph with some nodes and some connections between them, but notice what it's missing. There is no commonality between sneakers and running shoes, for example. We can make this better by adding in the semantics, where we could connect a shoe ontology and a color taxonomy, so that indigo is also connected to a cold color, or bright crimson is connected to a warm type of color. And just like that, you get more information. In the plain graph case, can be useful to have it, but you cannot generalize. With semantics, you can now generalize. But we can do better. So the last step in this process is to do inference or reasoning. So with our inference engine, we're able to infer newer connections. So what you see as a dashed orange line is the connections that have been inferred. And please note that no human has actually typed this one in. So inference and reasoning fits very well with a knowledge graph. So how does domain knowledge and inference can help in practice? Some of the benefits is that it can easily, you now in your knowledge graph with inference, you can easily answer an inquiry about blue sport shoes. Whereas if you have done that with just a plain graph, you would not get any results in a search application, for example. This can be done using faceted search and also via a chat interface, just by typing a natural language question. However, not every graph is a knowledge graph, as we know. They are not about searching paths between the nodes. They are about putting data into context via linking and semantic metadata. They are structured, interlinked metadata of entities and concepts. They have descriptions of formal semantics that lets humans, as well as machines, to process unambiguously or ambiguous semantics or text. And like I already said, they include rules with inference reasoning from relationships. So far we've talked about what a knowledge graph can do, but we zoom out now and we imagine the enterprise. So in the enterprise setting, you would have on the left-hand side something like unstructured content. This could be millions of documents, SharePoint slides, you name it. And here you could what we do is to automatize these platforms by extracting and managing and analyzing these relationships, thereby constructing an internal knowledge hub with all that information into one place that is harmonized and is readily accessible. On the right-hand side, you have the semantic data fabric, what we call the semantic data fabric. And here is where you virtualize your extraction and transformation process, and you can query also your knowledge graph. A knowledge graph is only a knowledge graph when you can query it, and not before that. So when you have this data catalog in the semantic layer all built in, then you can leverage this in your applications. This can be a GenAI chatbot interface that you have for some specific purpose, or an end-user app, or a BI dashboard to produce some sort of analytics, and other downstream analytics pipelines. So in a nutshell, semantic layer is a combination of a content hub where you have your data ready to be searched and enriched with relations and entities, plus your data fabric where you can query it and automate some of that querying system. And a conceptual model. This is where the semantics comes in. And all of this can be empowered by generative AI. And this, you see all these icons from ChatGPT in different parts of this diagram, where you can even have some sort of help there. So these GenAI applications can be applied in different parts of your extraction workflow. What else is everywhere these days is RAG. So what is RAG? RAG stands for Retrieval Augmented Generation. And it is a technique that is used to improve the accuracy and reliability of a large language model. Before responding, the LLM consults a separate source of knowledge or a knowledge base that you have stored somewhere, and this lets the LLM to use that context to ground in some way or form its knowledge before giving you an answer. So the typical workflow that we see, or in traditional or vanilla RAG, is that you have texts in some way, or it could be Excel sheets or whatever, and you take this and then you chunk it. So you break it apart into disjoint pieces of knowledge, and you use an embedding model to represent this into a numerical format, and you squash all of this into averages. So what do you do with these vectors? You put it in a vector database, which is very optimized to deal with these representations. And every time you want to know something, there's a similarity query that retrieves the information for you. And a prompt, of course, or several prompts that you can have that define how your user answers should be displayed. So that's RAG. Yes, but there's problems with vector RAG, and typically this happens at multiple steps. So first of all, the chunks, when you now have broken apart all that rich information in your PDF, it just leads to noisy embeddings because you cannot embed the whole thing at once. So embeddings is a statistical representation of this knowledge. And of course, if you know anything about statistics, you know that there's a lot of approximations that happen here. And approximations, they lead to information loss. So there's also problems with questions. When a user asks a question, how do you deal with the ambiguity of a question? Or maybe it's a very short question. And and there's also problems with the embeddings not being similar to the embeddings of your vector store. So this brings about some ambiguity, and of course this leads to suboptimal answers. Yeah, so basically the main problem is this chunking procedure. There are several ways in which you can chunk, and some more simple, others more advanced. But the biggest problem is that it is treating text as independent pieces of information, and the dependencies between these relationships are simply lost. I'm not going to go through this whole list of common challenges, but there are many. The biggest problem that we try to solve is related to data quality and relevance. So with a graph, you can increase or decrease the likelihood of having less relevant answers retrieved. Also, the transparency of query results is subpar as compared to other approaches because you cannot easily establish provenance, and that's also a reason to use a knowledge graph. There's also no contextualization in the vector. So although embedding models can understand a lot of the structures that are in some sort of information and can reproduce those and predict them, in the case of text, there are multiple senses depending on the context. So you cannot just simply break that down. And it struggles to connect the dots for questions requiring traversing disparate chunks of data. Yeah, the rest you can read it yourself. But, okay, so why am I saying this, and what is GraphRag? You can leverage your knowledge graph to do a better version or a more advanced version of RAG. And this is simply a specialization of advanced RAG that integrates the domain-specific knowledge models and retrieves information into the generation process. It enables more informed and contextually grounded answers, and it does enhance the accuracy and provenance. But the most important thing for me is that it captures the relationships of entities across chunks and document hierarchies. There are 4 main advantages of GraphRag, or how can GraphRag really help is, for example, it can facilitate the connection of terminology, for example, such as linking physiotherapy with coverage. If I now ask, does my insurance cover physio, it will be able to not only tell me what my insurance cover or what is physio, but rather the connections between physiotherapy and coverage and all the risks associated with that. Another advantage is that it enhances multi-hop reasoning. So what is this? So when you have a knowledge graph, as you all know, of course, this empowers you to generate more complex queries that, you essentially trace interconnected text via hops in a network. Yeah? Or in this example, you have pieces of text that are interconnected, and you have a pathway towards an answer. You have a drug, you have a pathway, and then you have a side effect. These are simple example of 2-hop in a multi-hop setting. And of course, semantic web technologies enable us to do this very efficiently. Another advantage is the ability to reduce noise. So when we focus on data connections, this decreases the likelihood of hallucinations or retrieving unrelated information. And of course, this is also related with guardrails. A knowledge graph is a sort of guardrail in the context of RAG and can be used as such and should be used as such. Another advantage, or final advantage, is a clear entity recognition. A knowledge graph aids you in distinguishing and disambiguating entities and terms. So, for example, a knowledge graph would be able to differentiate various types of cancer, like ER2 is also known as ERBB2 molecule, which is, you don't want, especially in a healthcare setting, you don't want to just rely on the general knowledge of an LLM to know that. So how does these things combine? So once you have an LLM that can leverage on a knowledge graph, it's like your application has now an interconnected brain before it talks to you. In this example, we have a simple example, which employees are a good fit to work on a new project for Octane. And you see this graph representation together with databases. And you can immediately see that in the first hop or the first try, Octane is a customer. So we know that because we have explicitly defined that in our knowledge graph. And they've commissioned a new project. On the second hop, the system spots ACME 2030. It's a past project with comparable requirements. And on the third hop, Bakir delivered Acme 2030 successfully, so he's already familiar with the domain. So your answer would give you the correct answer that Bakir is a good fit because he has worked before on this project, and this project has similar requirements, and also Alex pops up because of his specific graph skills, which are also needed for the project. That's just a very conceptual example. Yeah, so this is a list of our AI killer apps, and yeah, we have different verticals that we, not just life sciences or healthcare, but also financial services. Some of these are public also. Statnet is one example. It's the Norwegian Grids Operation Energy Infrastructure Service that leverages also a GraphRag application using GraphDB and our system of transforming natural language questions to Sparkle queries. So this is used in their digital twin application, and some other ones, but we can talk more about those later. An actual scenario that we tested. This was in the context of hydraulic systems, and you can imagine a user, Stefan, who asks a specific question about a technical product. He asked the chatbot based on a vector RAG, but he's not very happy with it. This is an actual problem that we addressed, an actual customer. Sadly, we cannot name them. And yeah, so they were unhappy with this. What if the answers to his question actually show him what he's looking for by leveraging Graph AI? We did this, and in fact, we have evidence that specific quality metadata, and here we also use data, as some of you might be familiar with this type of data structure, as part of the workflow, and they were quite happy with this. But don't take it from me. Based on the evaluation that we've conducted together with the customer, we showed that GraphRag outperforms by a lot on all categories. We defined some incidence categories on failure of hydraulic systems, and this was analyzed against a golden set of answers. Another use case or industry use case that might be interesting is an agent, a compliance advisor agent that we've developed as well, where we use basically what are the applicable policies for finance change delivery team and the role, context, and jurisdiction. There was a lot of law type of documentation where we parsed, and then we also quantified using a data model and a knowledge graph, and we're able to help them to infer what kind of risks it was posing, some conflict of interest outside some activity. Yeah. So lessons learned. We have experience, and I have experienced personally, that a small enrichment, even with a small graph, is already improving a lot of quality. We also had situations where completely unstructured content and not so large taxonomies and ontologies already helped and proved to be more reliable than just baseline or vector-based approaches to RAG. This can be at a new class in an ontology or shackle rule. This already helps a lot. This is always easier and simpler than just prompting the same semantics in natural language. And in different domains and applications and data require different RAG strategies. There's also still not a one-size-fits-all approach here. And of course, we pay a lot of attention. You have to pay a lot of attention to the data pre-processing stages, this data transformation. The ETL part is really, really important because even with GraphRag, garbage in, garbage out still applies. So using public...
they will talk to us about compliance and the usage of knowledge graphs for that. The stage is yours.
Yeah, thank you for the invitation and the possibility for us to present our project, Leipzig Semantic Web for modernization of public administration register information. We worked in this project last year, and Daniel, my colleague, was the lead developer, and I was the lead project manager in this project. Our presentation is divided in 3 main parts. At first, I present you Leipzig in a nutshell, then Daniel gives you some more technical insights in our project, and at the end, we will talk about the learnings. So let's start with Leipzig in the nutshell. Yeah, our main question was, with this project, we wanted to answer these questions. Can evidence requests in, we are here still and always on the level of data field, be used for the modernization of public administration register information, and can we use the knowledge graph as a base for the model at least? Our approach was that we used in the beginning the data for registration and reporting from DSMELT, and then when we go further in the project, we use data from law enforcement and registration. The results we expected were that we get more insights about the use of the graph and the digitalization of public administrations, and also that we recognize best practices. So some facts about the project. We started in March 2024 and ended in December. It was a project from the FITCO, financed by the IT Planungsrat, and the project leader was the Ministry of Finance of the Federal State Thuringia, and we as INET worked strongly together with Bechtle as project leader, and all results are licensed by CC by 4. Our approach was a methodical research approach. That means it was highly under like in a laboratory, that we built this knowledge graph, and at the end we not only gained the graph but also wrote a study of our results, which you can read on the homepage of the Ministry of Finance of Thuringia. So in fact, we had 4 main questions. So one question was, how can a knowledge graph work for administration? What for kind of data can we use, and where do they come from? And what software is required, of course, and which kind of relevance do we have with all these questions and the project? And at this point, I want to give to my colleague Daniel to give you more technical insights.
Thank you very much. At first, I guess I'll have to explain a bit, because modernization of registers is not the easiest of terms, and maturity levels, I think, need some explaining. What we aimed for was maturity level D1, which means data field level. To explain this, for the modernization of registers, there's a whole span of maturity levels. Maturity level A would just be an offline form that you get, and you fill it out, and it gets put into a folder, and that's that. While the long-term goal would be D2, we don't need forms at all, because the question contains what data fields are actually required. D1, what we were aiming for, would mean that we still process formal forms and evidence requests, but we only reply with the data fields that actually are needed to answer it. So, for example, if you had I don't know, religious affiliation as part of a form, and you don't need it to answer where a person lives. It would not need to be sent. Bit out of there as an example, but I think you get the point. So to deal with this extremely specific information, we at first needed an ontology. We decided that standardization would be the best approach because it's rather easy building just the ontology you need, but it makes much more sense to reuse what's already there because you get interoperability, you get the ability to adapt to other systems, and well, there's just more benefits than drawbacks. What we primarily used were the core criterion and core evidence vocabulary and the core public service vocabulary because they provided us with most of what we needed. We are in a very formal setting here. You have a public service. The public service contains certain evidences, contains certain information concepts, and you have some evidences that are used to fulfill evidence requests. So this sounds extremely formal. As an example, I need to know where a person lives. Basic example comes from registration. I need to know where a person lives. To do that, you get the certification of registration, Meldebescheinigung in German, which is used to give this person lives in this street at that postal code, etc. Where we found this is where we found our first stone in our path, because we are at a level where standardization is not at the point where we need it, actually, because first name, last name, address, these are simple concepts, and I guess each one of you would be able to answer what an address is, but it's not formalized. Sometimes you need to give the country, sometimes you need to give additional information such as what level of a building the address is in, the flat is in. So it's not standardized. Sometimes first name means first name and maybe second name. Sometimes it doesn't. So we can use relations to show this within a knowledge graph, but we can't just assume that the first name is a first name just because it's named the same. We have different levels that are used on that knowledge graph. We have the usage. Why does a public service require a field? We have similarities of data fields, which I talked about just now. We have the Reifegrad, the information on evidence. So do we get the data fields we need? Do we just get the evidence we need? Or supposedly, do we get neither? And there's not a one-to-one ratio between evidence requests and evidences, because not everything is, again, as standardized as we were hoping to get it. If you want to build a public knowledge graph on all that information, which would be possible, you would also get into a problem of governance, because somebody would need to register who puts that information in, when is it added, what version of a data model is used, is the information valid, what status is the data field in, and all of this would need to be collected on multiple levels. So governance is a huge question here. And I see I need to speed up a bit. The software stack we were planning to use was quite simple, actually. We had some requirements. We needed to edit it. We need to store the knowledge graph. We wanted to visualize it, and we needed to be able to run requests on it, because, as you just mentioned, a knowledge graph is not a knowledge graph if you can't run requests on it. We used simple Turtle RDF files and Shackle files for the validation. We used an external validation tool, and we used, for the sake of the project and the scope of time that we had, all-in-one solutions, primarily Stardog, if I remember correctly, to visualize the information. This had its own caveats, though. The next point in standardization is reusing is fine, but you need to get your learnings across. So what we did is using the EU core vocabularies, but also reporting what change requests we actually had. I'm hurrying a bit, I'm very sorry. The second important point is we used interviews to sustain the data that we actually had in our graph. So as Katharina just mentioned, we used the DSML fields as a basis, but then we went into Jena and did some actual interviews with the Sachbearbeitung, I don't really know, so with the civil servants actually processing the data. Let's say it like that. What we learned is, in short, there's the data that's formally required for evidences and evidence requests. Then there's the data that's formally taken for these evidences and evidence requests. And then there's a third layer, because that's what is actually in the form. And what we learned is, in the example of Jena, that the forms actually required additional data fields that were not part of DSML, while other data fields that were part of DSML weren't required at all. So we have a gap between practice and theory here, which needs to be bridged. And there we get again to the problem of governance. You could build a knowledge graph that supports all this, but you need a precise governance, because somebody has to say what's the right data. I'll skip over that and go to our learnings, I think.
So I quickly come to the end and will show you some learnings. I highlight only some points because of the time, and so that we have enough time to come into discussion. Yes, as Daniel explained, the standardization increases interoperability, and also it's also very important that the public graph always have governance, so it's in the process of using knowledge graph, and not only using, also developing, very important that the builder, the analyst, and the user work together and get the same idea for what they want to use it and how to use it. And also we learned in our project that's really important to have not only the right data, but always keep them actually, so that you always have actual data. The second learnings for us were, as mentioned, that big benefit for us were the interviews we did with the city of Jena, because getting contact with the employees in the public organization helps a lot to understand how they use which form of data. And of course, as mentioned, the EU interoperability is an important fact, so the inclusion of standardized vocabularies improves data exchange to and from the EU. Last but not least, it's a highly political field. The modernization of registry is always then win-win situation when it's possible to work strongly together with the ministry to get the same idea what to do and how to bring this modernization quickly to citizens, but also to industries. So I think that's the end. Thank you for your attention.
Questions? Okay, maybe I have a very quick question. It's very interesting how you conducted interviews with the people, and maybe that's not a topic that comes up very often, but how was it received by people? Are you taking over their jobs? Were they accepting the interviews? Were they receptive of the questions? What do you think?
Yes, so we had the chance to visit different organizations of the city of Jena, and it was a very friendly and kindly atmosphere. And Jena is a city with a highly grade of digitalization in their public services. So it was for us really interesting, and for the employees of administration were also interested in showing us how they work with all these different systems and tools. And so they were very open, and it was really very helpful for this project.
Thank you both so much. Yeah, sure. Very quickly, please.
Met correctly now, and you're also saying that there's EU standards that need to be kept. So but right now it's not possible to do it for Germany. So is there any plan how to get there? So to build this up to that level that data is in a standard Europe-wide?
Basically, yes. That's basically what the it's a horrible acronym, modernization of registers is about. So what's currently being built is the NOOTS, National Once Only Technical System, which will connect to the OOTS, the EU Once Only Technical System. And that is supposedly to facilitate data interoperability between registers from different countries. But, well, as mentioned, we are running into some huge hurdles.
Just as a comment on the addresses and ontologies. So this is a notoriously difficult minefield because address data is highly culture-specific, super variant even within countries. So I know ontologies who have to deal with that for global addresses, and they usually opt for super coarse data properties, like fill in the rest in this field, because the variations are so large, like this completely different addressing logic, for example, in Japan or so. So it's not that people didn't try, they just didn't really come up with a convincing pattern that is fine-grained and applies everywhere. So probably won't change.
I can't completely agree, but we can hope to at least standardize it for Germany.
Right, thank you, Daniel and Katharina. We're all suffering from bureaucracy, so we're rooting for you.
Thank you very much.
All right, next up is Daniel Schlichting. Yeah, he works in the automotive sector, and he will talk to us about how they use data linking to keep transparency between operational data and development data. Thank you.
Thank you. Thank you for inviting me here today to share our use cases. Today I will speak about verification and traceability in automotive software. Verification and traceability are very important because each car, or when we want to release a car, needs to be compliant with certain standard and requirements. For example, functional safety, security, etc. And we need to prove that all the software components, parts are really on the car, which are needed to fulfill the safety. But on the other hand, we don't want additional software parts which are not required. And today this is ensured by manual processes, which takes a lot of effort. And I want to show you an option how to use data engineering to improve or accelerate this process. My name is Marco Schlichting, and I'm from ITAS. This is an automotive company. We provide automotive stacks and automotive tools. You see there on the right side a transparent car, which is basically, we call it EE architecture. The violet lines are the network, the buses in the car. And then we have these gray boxes. These are the electrical control units, basically the computational platforms. On these ECUs, there are microcontrollers and microprocessors. And we provide there the middleware, which connects then the hardware with the vehicle functions. And just to give some example, one of these ECU may have connected hundreds of sensors and actuators to show a little bit the complexity here. Then if you want to bring such a, or when you want to develop such a car, you need also to debug, to fine-tune the car, for example, for diesel engine options or for the exhaust gas system. You need to set certain kind of parameters. Therefore, we offer measurement and calibration tools. For example, for autonomous driving, you can imagine if you have 12 cameras connected in your car and you have a problem, or you have detected a problem and you want to debug it in your laboratory, for example, then you want to replay these data streams, for example. Then also this car is not only has an internal network, it is also connected to the outside world, so also security comes into play. And when it is then in the field, you probably know that when you go to the car workshop, that you can go there and the mechanician can diagnose your car, and then it gets an error code, and then you can say, okay, sensor XYZ is broken, for example. So we offer also these kind of diagnostic services. So our middlewares are in more than 4 billion cars. We are globally present, and we have more than 350 plus satisfied customers. All the global players are our customers like VW, Mercedes, etc. So what are the challenges today? So our standard way of developing automotive software gets really under pressure. Our customers want online updates during when the car is already in the field. And on the other hand, we need to prove that it's still compliant to safety, security, and other standards and norms. And also the system complexity is really high. We see there are dozens of ECUs which run millions of lines of codes, and also the verification is really beyond human expertise. And on the other hand, we have then a tool, or let's say process landscape, which is really fragmented. So we have the hardware providers, which provides us maybe for one semiconductor 10,000 pages of PDF, which may describe then the functionality of these ECUs. And on the other hand, we need then to develop software according to these PDFs, etc. So there is really a good chance for misunderstandings. And also there is no chance for automation, etc. when you have these manual steps in the middle of your processes. So our approach is to have an integrated data platform where we centralize those data from different organizations, department systems to make it easier to collaborate with each other. That would enable us to automate tasks, to have fast feedback loops, and, for example, running a continuous development and operation DevOps cycle. And in the end, it would also be the base for enabling smart technologies like GenAI or artificial intelligence, like machine learning. So for this, we built a kind of demonstrator car. We are, as I mentioned, our expertise as a middleware. We do not build full cars. So we have here on the right-hand side a small demonstrator which has really a nice feature. It has a LiDAR for distance measurement. It has a depth camera for environmental recognition. It has also network features like 5G modem, Ethernet switch. And sure, it has also automotive-grade hardware like a vehicle integration platform. But on the other hand, it has also Raspberry Pis, for example, for edge computing. So, and the software stack is on the left side. We have here basically the black boxes as a hardware layer, which I already mentioned. We have a lot of sensors and actuators and the communication buses. Then we have over it the microcontrollers, microprocessors, and on these our middleware runs, which is, for example, the AUTOSAR Classic for real-time safety systems. We have adaptive for high-performance computing, or ETA's deterministic middleware solutions for autonomous driving or assist driving assistance systems. And then the light blue box for edge computing. And basically on top we built a distributed application which is horizontal to all those blocks. And you have to imagine here it looks very simple that those gray boxes are just simple connected, but to get a signal from the motion control, for example, to the monitoring app, we need to go through the classic stack, through the hardware, through the network in the bus, and then we go on the adaptive side up. And all these options the developer needs to be, documented during the development, but it makes the complexity so high. So the big challenge here is really the system integration, to bring the software on this hardware and really ensure that it's really working properly. So here's a simple example. So we have here certain kind of roles or actors who are participants. We have there the system engineer who maybe plans the full system. He makes the system requirements. He makes the system architecture, and he documents it in different standards, for example, RecIF or SysMLv2, etc. Then we have the software developer who codes and maybe writes documentation. He may use the AUTOSAR standard. He may use another standard, depending on for which platform he's developing. He may use also different tools and processes. Then we have the hardware developer, what I already mentioned. He provides a chip, a silicon, which is integrated in an ECU, which may even consist out of several chips. And then this ECU is integrated in the EE architecture of the vehicle. And at the end, the test engineer needs to test all these combinations to see if all the software functions run properly on this hardware. So we lifted those data via a GitHub pipeline into Shakel and OVL shapes. OVL described for us the structure, which we can see or understand each other or the different domains. And for Shakel shapes we use to make a verification to see if all data are consistent. For example, if we have a rule like there must be a review of the safety functions, we can write then a rule for it, and we can automatically run this and see if the review is older than the delivery of the function, and then we can say, okay, this function is already reviewed. In other case, if the date is older, we have to say, okay, this function needs to be reviewed again. All this data is then deployed into a Stardock knowledge graph. And you see here in the gray shadow, we have about 3 million of instances. So I just extracted then the software components. These are the blue bubbles. And you see the complex network between, or the dependencies between those nodes. And you see also that one line between also described additional information like interface description, timing requirements, etc. So we have here a little bit zoomed out so that it gets a bit more clear. We have on the top, we have the requirement, which also maybe has more dependency. So this requirement has a requires a software function, and this software function requires and also a hardware function, etc. On the left side, we have the system design. That is more or less a logical layer. Here you can see that the car is a logical block which has a microcontroller and which has a software function. On the red box, we have then the implementation, so that it's really the real hardware, the real microcontroller, the real implementation, the real middleware, and how it is even integrated. And then we have on the right side the test and verification block, where then those system integration is tested, and all of them are interconnected so that we can easily trace back if all the links are available. So I have all software functions have a test case, and all these test cases are green, for example. So this single point of truth we used for our use cases. We have there one use case is the homologation use case, as I mentioned before. Each car, before it can be released, needs to be homologated. There are certain kind of functions which needs to be even today, even physically demonstrated that they are working. And if we are now coming to the point that we want to do software updates over the air, then this gets a little bit contradicted. Yeah, we need to prove that the homologation, which we did before, are not infected by our software update, which we are providing. And this we can do nicely with the graph. We are in impact analysis and can therefore really save a lot of time, a lot of manual effort. Another point is optimization. Basically, if we have all our data in one single point of truth, let's say we have the software part, the hardware parts, and also the integration parts, for example, real measurements from the car, all together, we can also now take these data for really optimization, the system design by hardware-software distribution, optimizing the network, etc., which is not possible if you have separate development for hardware, for software, and even different parts here. And another point is system analysis. In the system analysis, we use it if we have, for example, problems during developing the car. It is always very difficult to find the root cause. If you make a root cause analysis, all these components, as I showed, are really interconnected, and it could be any software component. So we combine the measurement data, which we acquire online, and use logical rules to really prune all the components which could not be affected to filter the components to a reasonable amount of components which we can then manually check. And we use then also the simple point of truth for a holistic pipeline automation. Basically, we work directly via API on the single point of truth and develop directly on it. To show that basically using the single point of truth directly really allows us for automation and for continuous proving that our data is still consistent. So when we change, for example, a requirement, we could directly see if through validation if this requirement is still valid or not. And to improve the testing, we take out of the single point of truth, if we have there also the hardware description and the software components, and we know which changes we did, we can then extract exactly those software components and hardware components and use a virtualization of those hardware components and run them in the cloud. So we can really do automatic testing of changed elements inside the cloud and really accelerate so the development process. It may be not 100% proof, yeah, as it is behaving a little bit different in a virtualization, but we can, for example, find interface problems, etc., already very soon before we need to go to the physical devices. And the last point is the AI perspective. We see that in automotive, large language models, or especially in our domain or for our tools, they do not have enough knowledge or data points that they would answer accurate. So if you use a knowledge graph there, we could use it as a REX, also mentioned there, and look up our data so that we have already found solutions, we can profit from them, and we can also create new solutions and verify them via our verifications in the graph if this is really a valid solution which would be really held. So, thank you.
Thank you, Marco. Questions? Yep. Yes, please, can you come up to the mic?
Yes, thank you for the presentation. In the former years, I remember that we used for all that what you presented, for example, Team Foundation server from Microsoft to connect all the test cases and the requirements and so on. Did you give up this or what is the benefit using knowledge graphs compared to the old traditional impact analysis?
Yes, I would say we give up. It was not possible to bring so many. Sorry, I had a former life in another company. Sorry, I'm not sure if I can speak there more detailed. But basically, there were so many business units involved. Everyone wanted to use another tool, and they wanted to use a common tooling. And therefore, there were a lot of strategies to adapt this tooling, which was not really successful.
Okay, thank you.
Any more questions? Good, then. Thank you, Marco.
Thank you.
Right, next up is Dr. Sebastian Hellmann. He is the director of DBpedia. At DBpedia, they're responsible of broadening and deepening structured knowledge to use it for NLP and LLMs. So the floor is yours.
Yes, thank you. My name is Sebastian Hellmann, and I'm going to talk about the DBpedia fused knowledge graph today. So first, let's talk a bit about the data acquisition bottleneck. So there was a Forbes study in 2016 that asked data scientists, how do you spend your time? Like what data sets spend the most time doing? Yeah, and then you had starting with the dark green part on the right side, collecting data set 19%. Yeah, then another 60% in green, cleaning and organizing data. So these two steps, you would call them pre-processing, normally. And then building and training data sets, mining data for patterns, refining algorithms, and others make up the remaining 20%. Yeah. And if you work in data science, you actually do not need the statistics. Yeah. When I did my master thesis in 2009, I was doing machine learning. And I immediately had the feeling that the most impact on the number at the end, like the predictive accuracy or the F measure, was how well I cleaned the data. Yeah, so the more I cleaned the data, it's a very, the better the results are. And today I think many people, so the people are cleaning the data that goes into training the LLMs, for example. That takes a lot of time, removing racist texts, crawling the web, cleaning everything up. I know the people produced OpenGPT-X, yeah, they did do this. And also cleaning the output of the LLMs, yeah. This is also a big thing, checking correctness, making sure there's nothing racist or discriminatory in it. So this is kind of like totally matches the experience. So if you calculate this for one work year, you would have 80% pre-processing. Yeah? So January until October, you are working on getting the data and cleaning and organizing it. And then the last 20%, that is November and December, you can do the actual work, yeah? Like the algorithms and checking evaluation and building the application. So you always, in the data project, you always have this high delay and high opportunity cost, yeah, because your team could really do something better. So then I joined DBpedia also around 2010, but the project itself started 2007. That was when the first open knowledge graph was published. And I thought, okay, what is actually DBpedia doing? Yeah, so we are extracting and cleaning data from Wikipedia and Wikidata mostly, so these two sources, and then we organize this data in the DBpedia knowledge graph. So now with the fusion, which I'm going to present today, we are also collecting new data sets and doing the same process and putting it all together. But in the end, we are really tackling this 80% the effort of pre-processing for the data until you have a knowledge graph. Yeah, so what is this DBpedia Fusion knowledge graph? We see it as a ready-to-use knowledge graph, yeah, so it comes fully prepared for the most frequent use cases. We call this now the Start in January package, so you do not need to, if you have it, you do not need to wait until October until you build it yourself. And we also have scalable knowledge graph extensions. That means because it's Fusion, we are not limited to these two sources that we used before, Wikidata and Wikipedia, but we can add more sources flexibly and grow the knowledge graph. And it is convenient and reliable, so we are providing monthly updates, bug fixes, hosting, and ongoing support. I'll present some numbers of the current Fusion. So we are using the standard, the DBpedia open data set that we're producing since 2007, so the English DBpedia with 14 million entities, and then Wikidata with 117 million entities. And together, this sums up to 122 million distinct entities after Fusion. Yeah, we split the current release in the following files. And the current beta release in the following files. So we have multilingual labels and descriptions. Then there are ontology relations, 300 million facts, classes and categories, same as links, and images. And together, this new knowledge graph at the moment has 8 billion triples. Now, the types of the entities that are there, it is truly a multi-domain knowledge graph, because at the moment it is still only using Wikipedia and Wikidata, so there are persons, places, work of arts, biomolecules, cities, organizations, athletes, films, yeah, sport, film. So this is a multi-domain data set. And we built internally a pipeline that uses Akka for streaming. So while we are producing dumps, the system itself handles live updates. Yeah? So our speed now to process all this data based on the dumps in batch mode is around 3 days, where 1 day takes up this fusion. Yeah? So you have an extraction part and a fusion part, and we are at the moment at 2,000 clusters per second. Yeah? If you compare this to Wikipedia, Wikipedia has around 2 edits per second. Yeah? So just for the speed comparison, how much scalability is left. Okay, so this is the current state, and now we're talking about this methodology of growing the DBpedia Fusion knowledge graph from linked open data. So this is an image from 2007. We published the knowledge graph back then, and other people copied the pattern, published their knowledge graph, and also linked to us. Yeah, so very few data sets in 2007, but then over the time this grows. So today the image contains 1,500 knowledge graphs around. This is 2025. Yeah? But I think at some point people couldn't, knowledge graphs could not be added anymore to this image. So this stopped at some point, so we do not know whether how many more there are. So what is our position there? Since we were very first, very multi-domain data set, the people started linking to us. So this resulted in DBpedia being the most linked data set in this linked open data cloud. We are a hub and an authority. So hub means we have many outgoing links, yeah? And we are also an authority. And now, if you want to acquire data from this linked open data cloud, that is actually quite hard, because you need to find the different data sets, the vocabularies, the links and everything, and then fuse it and integrate it yourself. Yeah, and the DBpedia Fusion here will do the hard lifting, so 80% collecting, cleaning, and organizing into this Fusion knowledge graph. One example here, so this is one of our next target. Yeah, so we'll add more DBpedia language versions, and then this data set as well from the German National Library. So how does this look like? 12.2 million persons in the current Fusion, 6 million persons in the German National Library, 2 million with links of DBpedia, if you take 12.2 million plus 6 million, then you get 16.2 million because you have an overlap of 2 million and 4 million new entities. Yeah, the overlap then will be used to make the existing entities that overlap richer, so you have more relations, and also fact check and cross-reference the existing relations. Yeah? So this is how the fusion works, but the entity size can kind of like grow scalably very well. Now I'll present name a list due to the time. I'll name a list of use cases that have been working for 18 years. So this is something that people use the normal DBpedia, the EN snapshot for since 18 years. And of course, this works much better now because we have the fusion, then you have more validated data, more data. Yeah? So the kind of like the use cases work better with these, the existing ones. So what did people use DBpedia for? Bootstrap, like they took this as a basis for an enterprise knowledge graph or for their own knowledge graph. You can upgrade your enterprise data. That means you can connect your databases and analyze documents. You can use it as background knowledge and structure for machine learning. For example, Meta had this on the recent slides for their machine learning approaches, the DBpedia logo. You can enrich your data. This is very simple. You just take some images, some textual descriptions, put it into your knowledge graph. There's terminology grounding. Pool Party does that a lot. And search enrichment, which was presented by GraphWise as well today. Now here is an example. If you have an offline LLM, yeah, list head of governments of the 5 countries with the highest GDP as table, then you say no Googling, yeah, so ChatGPT should not use Bing, and you get a very outdated table, and this is quite clear that with fresh and validated data, you can fact check this, yeah, out of the box. So this kind of data, our Fusion Knowledge Graph can fact check. Now we are releasing this DBpedia Fusion Knowledge Graph sneak preview. So this is kind of like the first beta release for testing. We have adopted the business source license 1.1. So this license, it is free for research and non-productive use. And it is quite good for us because we can make the full dumps available. Yeah? So all the researchers, they can download the whole data set. Yeah? There's no limitations to it, and they can experiment this, write papers, do everything. Then we have an additional license for production use when there is value generation involved. And we put the price at 3 person months because we think it will save 10. Yeah? So that is the idea around. So for research, we have not encountered any barriers now with the business source license 1.1. If you have a problem, please write us. Feedback is welcome. Research should not have any barriers there. The open data sets that were open will stay open. This is also a good thing, yeah, because they are input for the Fusion Knowledge Graph only. We can leave them open. And we will publish new interesting data for new interesting problems. You can do linking, mapping, data quality assessment, scalability, everything. Yeah, build your tools with it. Prototyping is also cool. So for industry, we want to build a ready-to-use knowledge graph that you can just take, subscribe to, and then you can, it will fit for the most common use cases. Yeah, this is the goal. So out of the box. We provide the business convenience and reliable, so we'll have a contact partner and address issues when they arise, monthly updates, bug fixes, hosting, and ongoing support. And there's the possibility to steer the expansion of the Fusion into the domains relevant to your company. Yeah? So if you are in the health sector, we can integrate more health data. If you want business intelligence, that includes company data, or maybe new bitcoins or something like this, yeah, new cryptocurrency, some financial trends, fintech, and also industry 4.0. So the graph can be extended into the domains one thing I have to say, we will not go into very specialized data. Yeah? So at the moment, we're the short head, yeah? So most popular data. And then what we'll achieve is kind of like this middle part, but not the long tail. So we'll not have everything, every little thing in there, but I think the middle part is already kind of like very useful to have that, yeah? And not do it yourself and get it yourself and merge it. Okay, so we put the register and download and try links into the slides, and contact us for a demo session, or if you should find the data that is relevant for you in these 105 gigabyte and these 8 billion triples. And we have a slide of the members of the DBpedia Association that have been with us for the last 15 years. Yeah? Many are here today, eccenca, GraphWise. Thank you.
Questions? Yes, please.
Thank you for the presentation. So one of the challenges for AI, it's the wrong data. We see many mistakes for many tools like ChatGPT or DeepSeek. So what's your strategy to do?
Can you repeat the question? It's very silent.
Oh, okay.
You have to speak louder.
There are many challenges for AI for the wrong data.
Yes.
So what's your strategy to improve that? Thank you.
Okay. I hope I understand. So the challenge is that the GenAI produces wrong data, wrong facts. Yeah. So the only way of checking facts is if you have the facts, right? So you need to know what is true, and there are different. You have to. Oh, sorry, this is the wrong direction. So you have to understand this linked open data cloud. Yeah. So this is like the web of data. It's an ever-changing web where you can actually acquire data and fact-check things if you get the right source. Yeah. Actually, AI should use this, but this is not so accessible because an index is missing. ChatGPT uses Bing to search for websites that contain these fact checks, yeah, for example. But you could directly fact check it on the data if you have reliable sources and find them here. Yeah? So now this is something which we'll build with the Fusion. So the Fusion is kind of like an index over this data because we are doing the entity linking. Yeah? And we are also providing the data. Yeah? So there is a way to solve this. Yeah? A short-term, middle-term concept. So DBpedia Fusion as a middle-term solution, and then long-term we could have more decentralized data storage. Yeah, Wikipedia, they only copied it from somewhere else. That is also something, yeah. So at some point you have authority data, yeah. Like you are a citizen of this country because the state defined you as a citizen of this country. Yeah, it gave you the ID card, for example. Yeah, so there's like authoritative facts are created by the state, especially. Of course, you can have majority voting or so. If most people believe that this is true, then it might be true or something like this. So there are different strategies for this, but it's good to have different sources, authoritative sources where you can fact check things against. Yeah. And Wikipedia copies from those, and Wikidata as well. It's not their original data. Yeah. It comes more out of this and out of the real web. That is also a reason why we extend it.
Sebastian, if I got this right, while linked open data web was just putting connections between the data sets as a whole, you go into the data sets, and for all the resources within the data sets, you do the linking per resource. Is that what happens?
Yeah, it's exactly, we have a complete linked data-driven architecture, so internally and externally. Yeah, of course, it kind of like if you do bulk operation, the dumps are nice, yeah, so you can download 100 million entities in one go. But the web has also changed, yeah. When this started, 2009, you could maybe do, it was a lot if you did 100,000 requests per day to an API. But nowadays, for example, Wikimedia API, I was surprised, like 1 week I did 60 million requests or something like this, yeah. So we have this, it can be a key value store. The internet has very good speed now. One of my PhD students had a server, he did 250 million requests per day on this machine, yeah. So we can use this almost as a database. I think we are not there yet, that's why we're aggregating it, yeah. But we will also deliver it on this one by one, like entity level, yeah. So it's an entity level idea.
So the most practical thing is creating lots of same as relationships between resources in one data set to resources in other data sets, so that you...
I think they're already there. Yeah, we just clean them up, and we had a concept called Link Master 3000. If you have a live architecture, then people can also edit these links, or you have algorithms that can patch them live. Yeah. You have always new entities that you need to relink, or you know, like every day maybe you find 2,000 new entities, and you need to create links. So that's why we're aiming for this live architecture. Yeah?
Thank you. Great.
Thank you for the questions and thank you for the presentation, Sebastian. Right, last but not least, Dr. Tony Tonchev. He works at the Connected Urban Twin from the local government here in Leipzig. So yeah, the stage is yours. If you're sliding down your chair because you're sleepy, just maybe stand up and refresh yourself for the last presentation. Sure.
So, yes, I speak today about our geo-based twin in Leipzig. My name is Tony Tonchev. I'm employee of the city of Leipzig, the office for geoinformation and spatial order. And I have a background of computer scientist and geoengineering, indeed, and I'm one of the team in Leipzig who is developer of the twin, of the digital twin of Leipzig. And the geo-based twin is part of this. The concept, what is the geo-based twin? We have a definition of the DIN spec 91607. I'm a co-author of this specification, and the main thing is that the geo-based twin is a composition of resources. And resources, I mean geo-resources. These are geodata, geo-applications. And the concept of geo-based twin is to define the spatial context of twins and the time-bounded context of twins. This is the base, really, for all twins of the cities. And we have developed in the project such Lego concept, Lego-like concept, that we built twins from parts. They are data and applications and some methods or models. This is the picture of this. and especially to realize this, we have one condition according to the data and business layer in the DIN specification 91/387. Data catalog is a part of the digitalization concept. So the main idea was to combine semantic as metadata with the data and to put them in a catalog. So in the city of Munich, they have realized this with SICAN and the so-called SDDI environment. This is a city GML 3 concept for modeling cities. And all come together. So we have we built at first a taxonomy, and then we will see if we make this a semantic or we use another solution for catalog like Conterra's SDGI. And so we develop the main question was what metadata will we read in the catalog. So we developed this taxonomy with two main categories with information resources and geofunctionality, and then we have find classes. Ach, ich habe.
Yeah, because they had
Okay.
the wrong view. Is it okay for you when we continue this way? Okay, thanks.
Okay. I have not the presentation now. I have no control over the presentation. I cannot change the slides. I'm not Mac user. Mac offers only one option, and you may say yes, 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 and then you can go away.
Du kannst doch nicht bewegen, das ist mein Problem. Nee. Und ich weiß nicht, welchen Shortcut. Achso, okay. Bin nicht gut. Nee. Ja, ja, aber da komme ich leider nicht hin. We need an advance.
We can start PDF presentation.
Sebastian, maybe keep it like this and just go to the right side.
Kann man das, ja, ich komme mit der Maus nicht hoch. Das ist mein Problem.
Mit dem Ding funktioniert auch nicht?
Nee.
Wir haben ein PDF auch.
Na gut, dann.
Oder du machst ein PDF jetzt, weil das war die letzte Version, du hattest die von seinem US während der
Die Präsentation von Sorry for this. Nee, das wollen wir ja nicht. Was machst du jetzt? Ja, ich weiß es auch nicht. Irgendwer hat irgendwas gedrückt und ich versuche das.
So, and then we find these categories for classification of the resources in a catalog. And then we search ontology relations between they. And the vertical relations are kind of relations, and the horizontal ones are part of relations. So, and this we can use in catalog. For example, CCAN is supporting RDF or SCOS semantic. And we can implement this, but this is a political act to decide if we do this or not. Now we got the resource, and we have the problem. We don't know what to do now. We have expected a sausage, and we have received potato mash with curry and chickpea. So, for me, this problem shows that semantic has weaknesses. So we have explored these weaknesses at next. And for the case that we have changed from semantic model of the city in CityGML2 to CityGML3, because the space concept was changed, the time concept was changed from 2 to 3, and it was expensive to migrate from this is like this potato mash for 17 euro, such project to migrate semantic. So, how semantic is dealing with spatial concepts? We have on the left side buildings. And if a building is changing the geometry in the time, so the solution for this is to have more versions of the geometry. So we must compare versions over the time to simulate the process of building, the life cycle of building. So this is the solution of semantic. And the second thing is in transport is everything moving. So we have for sensoric the solution of dynamizer. Dynamizer is a property which changes with the time, and this property is realized in CityGML3 as so-called domain extension. So we need such domain exchangers a lot of, to simulate processes with data. It makes semantic complex, and the growth of semantic is unlimited, and at time it can break. So for me, it's that, and it is expensive. So how deals semantic with instrumental concepts? The solution is, first we make semantic in the RDF variant of semantic. Instrumental concepts are escaping. They are owned by any object or by any subject, but they don't exist alone. So, and if we use extended grammar, for example, not SPO grammar, where instrument or is a part of this grammar, so it will be complex. So, and heterogeneous concept, on example, John is working on sheet metal with the hammer. Sheet metal is a heterogeneous concept. One property is the form and one property is the material. So how is dealing semantic with such At last, we have dealing with emergence. This is in the first presentation. The title was when the whole is more than the parts. So this is emergence. And for emergence, we, for example, air quality. This is a case of emergence. We have three different parameters, and these three parameters are connected to one quality. The quantities, three quantities are connected to one quality. So semantic is not the best solution for this. So the challenges are ambiguity, when concepts need to be interpreted new. And this is the difference between discovery. We can do discovery with semantic, but we cannot do inventions. And secondly, the granularity is really, through the growing complexity, a killer application. And interoperability, so is the question. Semantic is dealing with operational concepts very low. So what would be the solution? So we changed to knowledge graphs, but to leverage our solution, and we used for this the properties of graph APIs and graph interoperability. So this is the model of our graph API, and it is the same of Neo4j. So Neo4j has these components and is interoperable with some apps, and we have an app for reading relation databases, simple ETL process. We have app for transforming semantic in knowledge graph. This is the Neo Semantic app. We have app for analytics. There are two apps, really. Neo Bloom and Neo Analytic Playground. We have instruments for internal transformations, and we have also front ends. The front ends are dashboards and maps. The only what we not have is three-dimensional visualization, and so we have decided to implement our geo-based twin on these apps. And this is the result. Example, we have dashboards and maps. They are linked with the graph database through queries. Every app has a formular field for query, and this what we find in the database is visualized here. So it works perfect, and we have from Neo4j server solutions, it's open source and it is unlimited. So this one.
Very, very quick question for Tony. Yes.
Thank you. Is there like a WFS service or something so we can use this
It's not
data?
published now.
Oh, it's not public. Okay.
It's not a public service. It is in the development now.
Okay. Can you? Is this
But
a plan?
these are samples, and for first time we decided to show this because our project is going to the end, and we will not have many opportunities to show this before we go online.
Okay, I got that it's a preview, but my question is, will this be publicly available? And if so, can we use like
Yes, this is the
like WFS?
concept, but we do this in order to deliver geo information and geo services to the other offices. And the other offices can make compositions with their apps, and they can select our resources after requirements they have, and then can you configure such a solution for every use case for the other office. And then the offices will have a base twin and the special twin for the... It's Baukastensystem.
Yeah, cool. Is there some info when this will be published? Can I opt in somewhere? Can I get notified when we can use this?
At first, we must decide to buy a server and to install this for a server client application. This is a desktop application, what I show. And after that, we need some resources to implement this.
Okay, thanks.
But it's simple and it is quite clear how it can do.
Thank you everyone for your attention and thank you for the cool presentations. I believe there's coffee break now, so let me not keep you any longer.
Wir sind schon 3 Minuten drüber. Oder? So we are already 3 minutes over the start. So even though the room is yet not full, I think we can start.
Yeah.
First speaker is Annalena P. from Fraunhofer Institute. Which one you can?
IUSB AST in Ilmenau.
In Ilmenau. And she will present Achieving Interoperability in Energy Data Ecosystems.
Okay. So, hello, everyone. I hope you are refreshed. And now I want to present something about achieving interoperability in energy data ecosystems, a semantic approach to integration and standardization. Let's start with the challenges in the information exchange in the energy sector. The communication is based on the legal required information exchange between the well-defined energy market roles, like between the grid operators and suppliers. As you see in my picture here, there are the blue-colored actors, but there are also other players like the hardware provider, the blend manufacturer and forecast providers, and they are also very important players in the energy sector, but there are no uniform or standardized rules for the information exchange. But these players can play, oh, it looks like these are not, but okay, these players can play a really important role, because if all the data from all the players come together, we can help, or we can achieve that the grid is optimized more and operate the energy grid efficiently. Sorry. And the most important, I think, is to support the transmission to a renewable energy mix. And yes, sector coupling, for example, between the automotive sector and the energy sector. And all this data can then unlock innovation potentials. So with these challenges, we looked at what concept can help us to implement other communication in the energy sector, or new communication in the energy sector, and for that we choose the data space concept, and here is what it offers. So the European Commission defines that the data spaces should enable the exchange and reuse of data within and between sectors. So this concept can help to improve sector coupling. And data spaces are a collaborative management of federated information exchange, and also the Gaia X Hub Germany defines the data space that they are enable efficient use and data exchange by leaving the data where it is and only bringing it together when it is needed. Data spaces should be offered the use of federated and open components, and also helps with sovereign data exchange and common agreements, based on common agreements and rules. And there's another organization, the Data Space Support Center, that defines the data space as an interoperable framework that is based on common principles, standards, and practices, and that enables trusted data transmission. So what are the benefits of this concept, and why do we choose it for our, it is a little bit, no, not looking like it looks in my, but okay. So the cooperative thing is very good for us because the data space does not belong to anyone alone, and the group decides together. There is also the reuse of data, and this is how a data space should be. It should serve fair principles like findable, accessible, interoperable, and reusable data. And the other aspect, the federated aspect, is that the data is only bring together when it is needed, and this reduces entry barriers. So more organization and companies wants to participate in the data space if it is there is no central place to copy the data or move it there. Yes, and there's other thing, the open standards, and this helps to have a good data exchange, and because it's based on open standards. And yes, as I say before, the data sovereignty is good because the control of the data stays by the participants. And interoperable, yes, there should be the possibility of data exchange, and there should not, the people should not interact as a lot with the system. The exchange should be automated. So, and trusted data, this also generates the willingness to participate if the data is trusted, if there is trusted data exchange. But this all sounds very good, but there are also challenges if we have federated data and data sovereign and trusted data ecosystems. As you see before, this federated data ecosystems leads to a greater willingness to participate in the data ecosystem, but the challenge when you implemented a federated data ecosystem is that there is a lack of central control. It is a benefit that there is no central control, but we have the lack of central control, though there's no higher authority that sets the standards, and though we do not have authority that gives us the data formats, the semantics, and everything for the communication. In the energy sector, there's a heterogeneous system landscape. So we have different and often proprietary IT systems. And yes, this is then the tension between autonomy and interoperability. So autonomy of participants is a central principle, but without binding specifications, compatibility problems arise between the data source and things. And yes, as you see, the challenge is the interoperability, but we want to achieve the interoperability in the energy data ecosystems. And without this central data storage, there's a risk of this inconsistent interpretations of the data. And from our side, we think the only way to, I'm sorry, it's all a little bit not on the right place in the picture, but if there's no dependency between all the components, that means that we need to have the data linked to the meaning in all areas and components of the data ecosystem. Without that meaning, we cannot have an interoperability in the data ecosystem. And if we have the meaning in all places of the data ecosystem, we can integrate the usage of intelligent methods, although in every place we want to integrate it. So, for example, AI methods or other methods that are intelligent to work with the data. And in more short words, interoperability must be achieved at a semantic level in these data ecosystems, or not even shorter, semantic interoperability in this data ecosystem. So now I switch to one implementation. How do we did that? There are different components in the data spaces. I focus now on two parts where the data is used or operated, and the one is the offer description. The offer description can enrich with semantic, and then this can be enriched through inference with the knowledge graph. And this improves the search for offers, and also helps to have accurate description of offers. And another place or another data in the data space is transmission data. If we semantically annotate the data that is transmitted, the integration of the data across systems can be done. And the data is then, as you see, transferred with meaning. So we have a shared understanding of of the data in all places, or even from machines and humans. So this is my last slide, and this is one implementation, the one use case that we have in our energy data space. There are two backend systems. One is from the hardware provider, here in green color, so a new participant in this data ecosystems, and the other data backend system is from the grid operator. And the hardware provider wants to provide the physical components, but he describes his physical component as a digital twin in the asset administration shell, so as asset administration shell format. And this green cycle thing where connector is inside, this is a component of the data space, connector, and this links the systems to the data space, but we integrate a semantic mapping in the connector that transfers asset administration shell structure, then here, for example, in JSON link data, syntax, and in this example, open energy, ontology, semantic. And at the other side, then you not need to use the same system as a hardware provider, or the data provider. You can use other system, and in the connector from the grid operator, there's also a semantic mapping that links them the received data to the SIM format, and then the grid operator can use the energy grid simulation tool to use the digital twin indicted. Yes. That's from my side. Thank you.
Thank you for the presentation.
Yes.
All good. But maybe there's a question from the audience. Anybody? If not, you talked about your building digital twins. Yeah. What is the frequency? How often is the data updated? So what is the data or the amount of data you are managing?
Yes, at the moment, in this project, this is a research project, and we work with hardware components providers, and they build the digital twins. We are not building the digital twin, we are providing the data space infrastructure and the semantics and everything, but not the digital twin itself. And at the moment, we are receiving it per email and do it in our test infrastructure and upload it there. So it's not very often. It is, yes.
Okay, thank you. Next speaker is Dr. Miriam Eisenbart from FEM-Forschungsinstitut. She's presenting the project Kupfer Digital 2, enhancing efficiency and sustainability of the copper life cycle with semantic technologies.
Should I use these, or?
As you wish.
Oh, maybe better. Thank you so much.
So thank you so much for attending my talk. I want to introduce to you our new project, Kupfer Digital 2, Kupfer Digital 2. I myself am a material scientist, so today I give a talk about digitalization and ontology design from the point of view of a material scientist. Yeah, I hope this is something that gives you another perspective towards what we are doing in the material science realm. Since this is the data week in Leipzig, I have brought some data from our institute. So this is historical data from our institute. The institute is more than 100 years old today, and of course we didn't do digitalization from day one. So in the past, this is how we recorded our data. We have photographs glued to pages in folders, and we have some metadata written around our raw data here. So this is a micrograph of a gold alloy, where we can have some information about the gold alloy. It was cast, it has a microstructure. We learned something about it. But my point is, since this is not fully digitalized and not fully documented, we have only limited benefit from this kind of data today. So some data is missing for the interpretation of this, like the sample size, the sample geometry. And since this data is missing, we nowadays cannot interpret these data fully. Therefore, if we want to have this data, we would have to cast this again, go and buy gold. This is expensive. So in order to avoid such costs in the future, we are very keen to do better in the future and digitalize our data and describe it properly in a fair way. The project Kupfer Digital 2, as you maybe have guessed already, is a second project. So both projects, Kupfer Digital 1 and 2, are part of the Material Digital Initiative. So this is a rather large initiative in the material science community to drive forward digitalization. And the goal of this initiative is to do something that is a benefit for the whole community and is based on ontology design and on some semantified data. I have a slide from the PMD, the project, the platform Material Digital here, where you can see that there's a timeline with a lot of projects running. There was the first project funding round where Kupfer Digital was founded, a purely academic project. And now we are in the third funding round with Kupfer Digital 2. And this is industry-driven project. So we have a lot of industry partners. I can show you on the next slide here that we have 14 partners in total, 3 research partners, including Infi, which are here in the room, and 11 industry partners, including eccenca. And our goal is actually to build a whole cycle, or close to whole cycle, of a copper alloy, which goes from being cast into an alloy and then processed into a product, into then finally, not a full life, but then also the recycling we want to see. We want to do it in the project, and we want to also describe it based on ontologies. So this project has only just started. So what I can show you is what we plan to do in the project. We have several concepts that we are following. One is that we have our connector here. I have asked ChatGPT to give me some illustrations so that it's not only text-based. So we have our connector who is getting a digital product passport in our project. He also wants to write down all the LCA factors that go into his or her production. Then we have a demonstrator process chain, where we do a demonstrator connector really in real life in factories of our project partners. And we record all relevant data during this process to build up also a digital twin of our connector. And we are working closely together with DIN and DIN Solutions to also bring standardization to our project, so that what we are building up in our project can go into a standard after the project is finished. And also a large goal of our project is to be interoperable with the platform Material Digital. This is a prerequisite of the whole project, but also to Catena X, which is something that is very interesting for our industry partners. So we can have a quick peek at how our product is produced. So there's a process chain where copper scrap is put into a melt and then into a solid material, and then several process steps occur until we really have a material that can be characterized. And each step in this process chain will have an impact on the behavior of the material and ultimately on the behavior of the connector that we are producing. But as I mentioned before, we are not only interested in what is written here, the metadata process parameter and the measurement data and the properties. We are also interested in the impact that our process has in terms of, for example, a product carbon footprint. So we record also life cycle assessment relevant data. We have already seen in the predecessor project that this can have a huge benefit if we have more knowledge about impact data of our product. So in our predecessor project, we had an alloy development method that we applied, and we also did an assessment of the impact that different alloys have in terms of carbon emissions. And you can see that the choices that you make during design of your alloys have an impact on the results in terms of carbon emissions later on. So my point is, the more you know about what impacts you create during your processes, the more you can influence them and the more you can make informed decisions. And that is what this project is all about in terms of material performance, but also in terms of economic impact. So as I mentioned before, we have not done too much in the project yet because it's only just started. But I wanted to bring you a little bit about ontology design. So I'm going to go a little bit back to the predecessor project to show you a little bit what we were doing there and on what we are building up in the following project. So we have a workflow for digitalization where ontology design plays a huge role and where we also design knowledge graphs. And I want to show you a little bit about our workflow that we did here. And I will take you into our lab now, where we have a sample. This is a microsection of copper alloys. And we have my colleague, Katja, who's doing a hardness measurement on the microsections and gets a result. This is a hardness value. This is a very typical daily thing that we are doing in our lab, determine the hardness of an alloy. And now we can describe this with ontological entities like this. So material scientists like me, I don't have to write this down in a turtle serialization. I can build this up like this in graphs with a tool that's easy to use. And I can express what is happening here. A specimen goes into a measurement process and has a result, a biggest hardness value. Then we have an automated process behind this where these rectangles are then automatically transferred into a turtle serialization. My thanks go to the Infi at this point because they set up a nice GitLab for us to play around with, where we could put all our graphs in. We could just by an automated CI job create a turtle serialization and test if this is working or if there are any errors inside. And we had also documentation of this, and you can follow this link to see what we did in the project. So this is what maybe a knowledge graph then about the hardness measurement looks like when you take into account everything that you later want to query on this graph. And I have written there simple representation. It might not look simple, but it gets more complicated if you want to model more, like our colleague of the BAM who did the similar test, another hardness measurement, and had a knowledge graph that was much more complicated. Just wanted to show you that how what you want to model and what you want to query afterwards has a huge impact on how complicated such graphs can get, and we have seen this in the project a lot. So a little bit information about how did we model. We didn't build ontologies from scratch. So that was something that we learned during the project, that you should not do that. But you should rely on what is already published. And there was a lot of, let's say, discussion about what would be the ideal top-level ontology and mid-level ontology to reuse in this case. And we have, our colleague Hossein has published a nice paper where he did comparison between different top-level ontologies. So MO, PROVO, and BFO are the ontologies that we identified as the most used top-level ontologies in material science community. And in the end, we found that BFO with IOF mid-level ontology and MSEO were overall the best ontologies for our purposes to reuse. So a little bit about what is happening now with our experimental data. I have shown a little bit about the hardness measurement. This may look like this. We have something like Excel files or CSV files where the raw data are stored. We have used a eccenca that was set up by Infi again to store our data. And you can either automatically upload this by using a script or manually do it and have our data all published. You can access them freely. And to then get to a point where we have raw data mapped to our ontology, we have a tool set that was developed by the Fraunhofer IWM in our project. It's described in this publication over here, where an automated mapping to happens when you upload a new data set. So you have a mapping that is set up once for a specific method, and if you upload new data, this mapping happens automatically. And nowadays, we already have a connection of our old project to the PMD, because now the PMD data portal has been set up to collect all material science data that are published in this way. And this links directly back to our CCAN, where our data sets are maintained. And you can access the data portal, and in the future, it should hopefully hold more and more materials data as we go on. So this is the extent I wanted to show you today. I also wanted to introduce you to the partners in our first project over here. We have a nice picture of our project partners and also our new project partners in the new project, which is even larger than the first one. And one thing that I wanted to do was maybe invite you to a conference that we are hosting this year in Schwäbisch Gmünd at our institute. If you have now interest in learning more about copper, this is the way to go, to the Kupfer Symposium in Schwäbisch Gmünd this year, where we will also give a digitalization workshop tailored to engineers and materials experts. And I want to stay on this slide a little bit more. If you are now interested and have missed some of the QR codes that I gave before, this is the time to collect them. And yeah, everything is recorded. Okay, so that's it from my side. Thank you for your attention. My contact details are behind this QR code, and thank you so much. I'm open for your questions.
Yeah, are there any questions from the audience?
Yeah, you mentioned Jupyter Notebooks somewhere in the middle. One of my hobbies is to rerun them at scale. Where would I find them?
This is really just for uploading the data sets to the Sequen. I can give it to you if we didn't publish this one.
Okay, but do you have larger quantities of Jupyter Notebooks?
We have some in the publications. Not so many in the Sequen, I think. Don't recall so many. But yeah, sorry. If you want to get in contact, I can,
I'll try.
Can collect them for you.
All right.
So, hello, thank you for the presentation. It was great. During your ontology development process, I have seen that you mentioned about the analyze and reveal of the top level and mid-level ontologies. Yes. Your domain application is about the material science. I wonder, based on which dimension or aspect that you evaluate and select the most suitable top level and mid-level ontology for your application.
Yes, thank you very much. So the colleague that did the paper, he did most of the research into that. I think he found close to 100 published ontologies relating to material science. And I hope I don't cite him wrong, but I think the process was really looking into how many of those are really used today still, and in how many other ontologies are they used that are relating to the material science domain. And I think there was also a second paper out of another research group who came to a similar conclusion that the MO, the BFO, and the PROVO were the most still used ontologies in the domain. And another thing that played also into this decision was that the PMD core ontology, the overall ontology for all the projects that are related to this, they first used the PROVO ontology and switched later to BFO ontology, so those were already very much used.
Nee, aber das ist das Falsche.
Oh yeah, sounds good.
So, hello and good afternoon. So my name is André. Today I'm going to talk about knowledge graphs and fair principles applied to social science and humanities on Shock and Edit project. So a little bit of myself first. So I born in Brazil. I did my PhD in the Semantic Web area here in Leipzig, with the majority of these guys here. So, and now I'm working at the Vrije University of Amsterdam, applying semantic web to social science and humanities. So, and I'm the organizer of Semat's workshop as well. So, quickly talking. So, a little bit about the group that I work, the UCDS, User-Centric Data Science. So the research topics include cultural heritage, linguistics, fair principles, digital humanities, and more, and semantic web apply in diverse areas, including
social science and humanities. You can check more on the website. So I have bachelor students like in this area. I am a postdoc there, just to make sure that you understood. So in link prediction, fair tools, doing benchmark, ontology, alignment, benchmark and comparison of ontology and vocabulary repositories, all focused in data from social science and humanities. And so we have some projects here, like, and the project that I'm working actually now is ShockNL, Social Science and Humanities Open Cloud. So it's semantic web plus fair data applied to social science and humanities. So these are the people that I work with, okay? And so the project that I'm working with is ShockNL. So the aim is to facilitate the FAIR principles to social science and humanities. So we do like annotation and search, like majority of the tasks include like conversion of tabular data to RDF, query with natural language and LLMs, like with those models, and creating link sets between like common data, like for instance, like the most common right now is Wikidata with some particular data from social science, and providing APIs, including Sparkle endpoints, using the linked open data model, use like standard vocabularies and ontologies in order to get this interconnection between this heterogeneous data. And we have a service specific for social science and humanities that is Claria, where one of the aims is to identify missing vocabularies and provide a kind of like registry and repository for those vocabularies. And because, for instance, like in social science, the majority of people like don't use OWL, they use course. So instead of like to have classes, we have like concepts, and they don't have subclasses, narrow or broader, and so on. This is a kind of like small stuff from this domain. And the deliverables from the project includes a knowledge graph, which I'm working the majority of my time, and requirement analysis, visual interface, and quality assurance. A little bit of the knowledge graph that I'm working with. So the main plan for this is to develop an initial proof of concept of this knowledge graph, where the key aspects are like the model, the academic ecosystem in social science and humanities, and in order to capture those relationships between researchers, data sets, research software, and research papers. So we use this publicly available data only, and and we as a good practice in semantic web to use persistent identifiers such as like DOIs for papers and dataset, or guides for authors, and so on. More information you can read our data store about this knowledge graph. So where the data comes from, like from in this knowledge graph. So mainly we deal with private tabular data. Means like comes from CBS. CBS is a Central Bureau for Statistics in Netherlands. So, and to deal like with this, we need to have the like annotations on this private data. And if the people want this data, they need to fill a form and so on. And we have some code from some projects like Odyssey, where this ShockNL comes from, and some repositories and tabular data also that comes with vocabulary and thesaurus, and so on. So, some recent activities that we are doing there. For instance, like comparing FAIR tools with FAIR implementation profiles. Two different things, like FAIR tools, like they aim to provide you an automatic way to check if like your data is fair, like apply the FAIR principles or not. And the problem here, like we have like the same data set and different results according to the tools and according to the questionnaire also. So, and these questionnaires, this FAIR implementation profile, they are community oriented. So these grow up with social science and humanities, this FAIR implementation profile. And we are dealing like this. This was a paper published at LSWT like last week, and that's all. So, and another one is like making closed data fair. The case of CBS data, where they have like private tabular data and public metadata. So, like the aim here is like to annotate the columns of this private data, providing metadata. So then, like, in this way, like the data don't need to be open, but can be fair, can be, like the FAIR principles can be applied to this data, okay? Another one is, it's work from a PhD student, which starts with ontology alignment with LLMs and knowledge graphs. So he has an approach with 5 steps, like with involving embedding creation, like training sets of some models, and one case here that we got, the first one, is providing a kind of crosswalk, like matching like properties from code meta to Wikidata. And I am one of the organizers of the Semantic workshop, so which is a workshop aiming to join people like from Semantic Web and material science. So it's the second edition this year. So if you have some work in Semantic Web and material science, as the case of the previous presentation by Miriam, so this is a kind of your chance to have a place to talk about your work and discuss. So my former work was applying Semantic Web to material science, so at BUN. And the workshop, more hands-on, where the aim is like to create and find like reusing vocabularies in humanities and social science. So the name is Let's Talk FAIR. So this happened last week, was in Amsterdam during the conference DH Benelux, Digital Humanities Benelux. And we got like 2 recent papers. I would just talk about the most recent papers, of course. So one of the was the Best Paper Award, which is this enhancing provenance research with linked data, visual approach to knowledge discovery. So it was at the CMDH workshop. And that's all, and we are always open for collaboration and studies together. And I appreciate your time. Thank you.
Okay, are there any questions from your side?
Thank you for the talk. I have one question. You mentioned the ontology alignment.
Yeah.
And I was wondering if you have these closed data sets in the Excel files. I mean, if you want to match them then to ontological concepts, which you already saw, this is huge work if you do it manually. And I was asking myself if you use LLMs or other systems to help support you by the matching, through the matching.
Oh yeah, sure. Thank you for the question. Very relevant. So the relevance of this question is about you using LLMs in many tasks. For instance, ontology alignment. So our previous work, we are using LLMs to generate, to complement ontologies for material science. So, and then we realized that since we are generating this, is not link prediction, just to make clear, but we realized this, and for a small ontology, LLMs works good. Huge data, I don't have the answer yet. Maybe we'll have in next month, but just to make clear that I point to your question. My pleasure.
Yeah, thank you, André.
Oh.
There's the one.
You mentioned there was a research paper for this, I think. Is that public?
Oh, no, I mean, if you want a very good research paper about ontology match and ontology alignment using LLMs and RAG, there's the best research award from LSWT. It was just published last week. It's called OntoAligner.
OntoAligner?
OntoAligner.
All right, thank you.
Yes, definitely. And our work is a little bit different because we focus straightforward in data from social science and humanities. And this matter of because people majority use scores, and this makes all difference when we are talking about this. Just to make sure that. Are you satisfied?
Yeah, that's fine. Thank you.
Perfect.
Thank you for your presentation. My question is, for every project there is a major constraint, right? So I want to know, you spend more time for this constraint and how you find solution for that.
More time for this constraint?
Yeah, constraint, the theory of constraint, when you have something takes a lot of time. So, yeah, what's the part that it takes more time for you for your design? Thank you.
You mean only about the ontology alignment, or you want to talk
the process? Yeah.
This one.
Yeah.
I mean, the constraint that takes more time is to compare with the state of the art. As I mentioned that we this OntoAligner from the last week. So, and we were working in the kind of similar way. And then boom, OntoAligner comes. And then we need to rethink all this stuff. This will take I don't know, the student got a little bit how can I say, disappointed because it was a kind of competition, but then as a supervisor, you need to explain that this is not a kind of competition. The science needs some approach in parallel, and then just to answer you in a kind of very vast way, this constraint of time. So this constraint of time, that there's no exact answer, it's this way, we have the methodology. I mean, I can only say about my case, but there's no formula, generic, universal, accepted by the whole world. No, but my case is this one, about time constraint. Only my case. I don't think I answered your question, definitely not, but...
Yeah, because I have experience in research and industrial life, so always we try to detect time to market. So what's the part that we spend a lot of time, because it helps a lot for the business plan and for the approval with our client. The client can be a university, can be a company, so just to have an idea. Thank you.
Okay. No, I mean about like those type of time constraint, like to, for instance, provide a kind of product to a company. So this can be planned, of course, like because we can have a prototype and so on. But we are talking about more a kind of proof of concept here. Just make sure that.
Yeah, thank you.
All right. Thank you.
Pleasure.
Next speaker is Dr. Daniel Mietjen. He will present knowledge graphs in the context of the National Research Data Initiative, NFDI.
Okay, thanks. Yeah, the slides are online. If you are in the habit of taking photographs of QR codes, as we've rehearsed a bit, you can do it once more. And the slides do contain a number of links, and so having the slides at hand would actually be useful. Yeah, first, structure of the talk. I'll explain what the NFDI contexts are that I'm referring to when I talk about knowledge graphs in the context of NFDI. Then I will talk about those knowledge graphs in those contexts, and I will talk about interoperability between those knowledge graphs and others. First, NFDI. So it is actually used in multiple senses. So if we were to go down the knowledge graph approach, we would disambiguate it. I've done a provisional thing here and came up with like 6 different senses. I'm not going to go through them in detail, but basically one meaning of the term is the idea, a landscape in Germany where data is actually a valued citizen and a part of the entire landscape. Then there is a DFG funding line that supports some developments in this direction. Then there are a number of projects that are funded through this. Those projects, they run infrastructures and they come with a community. And also, since the projects themselves are not legal entities, there is a legal entity that also is called NFDI. So basically, any of those 6 senses are what I mean NFDI context. And if you really dig deeper, you can probably come up with a few more. With that in mind, there is an overarching mission that I've stolen from the legal entities mission because, well, the others are a bit less precise on this one. And so it's data as a common good for excellent research organized by the scientific community in Germany. It has the national in its name, and here it says Germany, but actually nothing that we do is limited to researchers in Germany. It's just that the funding line is German, and so we have to kind of acknowledge the funders in this way, but we're building this with the entire world in mind or with the entire discipline. Also, the projects that are funded, they are covering essentially all disciplines. It's roughly 30 projects that have been constructed bottom-up, and together they cover essentially all disciplines. But it's not just that you have one for physics and one for medicine and so on. Some of them are disciplinary, like mathematics that I'm part of, and others are cross-disciplinary. And they do work together. There's also a mission here, step by step. We're conscious that things don't go quickly. Here is a rough overview how this maps to the different disciplines. So social sciences, life sciences, natural sciences, engineering, very rough categorization. So for instance, mathematics is not necessarily a natural science, but hey. And also the timeline here, the original funding for this, like the funding line, the DFG funding line, was from 2018 until 2028, and currently a continuation is being discussed, but nothing is public about this yet. The individual projects, which are given by the acronyms here, they came in 3 different groups that run each for 5 years, and so some of them are finishing this year, and others are finishing next year, and then the third group is finishing in 27, and hopefully by then we know how things will continue. There is one odd one out here, and that's the base for NFDI thing, because that is a project that is essentially kind of handled by a group of these projects. So it's kind of a meta project. And the idea of this base for NFDI thing is that it should supply infrastructure that is relevant to many of those other projects, because any of those others, they kind of have their research field. It's high energy physics, or it's like culture or things like this, right? But there are things, and knowledge graphs are some of those things, that are relevant both to high energy and to culture, for instance. Yeah, so this base for NFDI project basically tries to look at the data lifecycle, workflows, infrastructures, communities around these standards, and brings the different consortia together on roughly 5 lines of interactions, and then they're discussing all these different topics. And basically knowledge graphs are one of the topics that are also being discussed. Here you see like projects that are then being funded by the base for NFDI project. And this includes, for instance, a project about Jupyter that I was just asking about earlier. We have something about data management plans, knowledge graphs, software in general. This is research data management training. This year's identity and authentication mechanisms, persistent identifiers, and terminology services. So all of these things are meant to be useful across different domains. And so these base services are meant to A, work together, B, work with many different consortia, not just with mathematics or culture, for instance. And they also follow a certain trajectory, and there's regular evaluations, and they all work very much in the open. With that said, I'm now zooming in on the knowledge graph thing. So we're like in the 4th level of digging into this NFDI infrastructure. And here we have a project that is part of those basic services, and that tries to basically support knowledge graphs, the use of knowledge graphs in that wider NFDI ecosystem. And it is in its initial stage, which is called the initialization phase, which comes before the phone call. Here, thank you very much. So the initialization phase is basically to take stock. Who in the NFDI context is already using knowledge graphs? What kinds of knowledge graphs are they using? What are they using them for? What would they like to use them for? What are the obstacles, the pain points, the sweet spots, these kind of things, right? And so we're in this process right now. We have gone a few steps. We've built a hub that can collect some of this information. We've built a registry, which is a knowledge graph that contains information about NFDI knowledge graphs. Yeah, and we're trying to come up with guidelines that make it easier for people to jump into knowledge graphs if they are not from a knowledge graph or semantic web background. Like the typical material science researcher or cultural researcher, they don't normally operate with a knowledge graph every day, and they certainly don't set one up. But we are there to help them set knowledge graphs up such that it helps them do their kind of research. And we want to do this in a way that works both for high energy physics and for culture and everyone in between. And you can see that there is lots of fun involved. Okay, here, brief overview, lots of acronyms. You don't need to know this. Basically, in black are those that are part of this knowledge graph project within the basic services. And those that have a KG here are indicated as already operating some KG, at least one. Many of them actually operate several of them. So that's the landscape that we're trying to interact with. And we're also basically running queries. We're thinking about personas. What would the people want to do in this knowledge graph? What would they want to do with the other knowledge graph? How would they want to link this to ontologies or other kinds of workflows and so on? The Service Hub is there to facilitate all of this. You can search and query for knowledge graphs and information about this and different types of, for instance, Sparkle engines, things like this. We have example queries. And all of this is just right now starting points. Here's an example query that is at the knowledge graph registry. It's the query that gives you the list of NFDI knowledge graphs known to that registry. At the moment, that gives you 24. That's not a huge number. You can probably imagine larger numbers, and you probably have heard of more knowledge graphs than that. But these are the knowledge graphs that are actually operated by those NFDI consortia. Now, on that basis, we're looking around, okay, what other knowledge graphs are these projects, consortia, or even knowledge graphs interacting with? Or could they interact with? Or where do you see potential? For instance, if you are in any of those research fields, you're running a knowledge graph, or you know of some knowledge graphs, how could we bring this together? What are the potential interactions where it might make sense to bring those knowledge graphs together? We teach people who have never heard about knowledge graphs. We teach them about the knowledge graphs and about how people who run knowledge graphs can use them and what the potential is, how to find out, how to test. We also help them survey the knowledge graphs in their field. I've linked here an example for biodiversity. And also we're helping people, especially those that are new to the semantic web field, trying to find their way. And typical use case is they start from some specific piece of knowledge, and now they want to find other pieces of knowledge that are related to that. And typically that knowledge graph doesn't exist yet. And so we want to make it simple, or at least doable for them to build this kind of knowledge graphs. We also want to make it simpler than it is currently to find out something of your particular interest in a knowledge graph that you don't know. So if you're a social scientist and you're in front of a mathematics knowledge graph, well, maybe you don't really know where to start. Or the other way around, you're a mathematician, you're in front of a history knowledge graph or so, right? Or chemistry. And so we want to make those things easier, for which we are thinking, for instance, of query stories, where we actually explain how rather complex queries evolve. What is the initial question? Then how did you ask the question to the knowledge graph? What kind of results did you get? And how did that basically influence the trajectory of your research? We also document how you can deploy your own knowledge graph. That's for those who really got appetite and want to do more. And we're using the registry, which is a knowledge graph itself, as a demo of doing this. And then once we have a set of knowledge graphs, then we also want to do federation. We want to make sure that there is a potential to use them together rather than just as a bunch of silos. And so we are standardizing, or at least we're trying to standardize things like variable names in the query and things like this, so that the uninitiated, somebody who doesn't know a particular knowledge graph, but maybe knows another one already a little bit, they have an easier time finding their way through those example queries, for instance. And keep in mind, this is all cross-disciplinary. It's rather complex, and so we would also be interested in collaborating with anyone who is working across multiple knowledge graphs. Yeah, and you can tell us about how you do this. Some more facets, questions I have in mind, or we have in mind with this. If you have an image like this, it's an image of a part of a monument, and that has Greek letters and all these kind of things in gray at the bottom. The question here is, for instance, which of the knowledge graphs should contain which piece of information about this? So the equation, for instance, could go into a mathematics knowledge graph, but it's actually a physical equation, so maybe it should go into physics. But it's relevant to biology and chemistry, and it's on a monument, so maybe the cultural people, it was actually on display today here earlier by the Zeiss people. And so there's lots of things that could be said about this, and the question is, how do we distribute it across the different knowledge graphs? And then maybe bits and pieces of the same thing sit in different knowledge graphs. How do we identify in those different knowledge graphs that we're talking about the same thing? And who decides what is the same thing, the same as, or same as kind of thing, right? Is, for instance, if there was a correction to a published article, is that still the same article in your database, or is it another article because there is a change? And sometimes this is not an easy thing to do. And there's a lot more questions. I've listed some more in blue here. And also, how to federate queries at scale, also how to debug federated queries. All of these things are not so simple, and we're diving into that, and we're trying to document the problems and the opportunities, and trying to take the community with us. We're in the initialization phase, I said. This goes until the end of the year. After that, hopefully, this is not entirely clear, there will be an integration phase. It depends a bit on how well we do in the first year, right? During the integration phase, we will have something that's called incubator projects, which basically means someone from the community, that includes you if you want, can come up with a project proposal and say, hey, let's do something with knowledge graphs. And then there is a process by which this is going to be reviewed, and we will have to demonstrate some usefulness of your idea to the wider NFDI community, and then we can do your incubator project. Yeah, and so we have a number of examples for you to get involved. You can share whatever you are doing with your knowledge graphs and think about how this could be useful to this national research data infrastructure, or maybe to another discipline or something like this. How it could be useful for teaching, both to students and to, let's say, data stewards or something like this, data engineers, data architects. Yeah, and we do have contact information, and there's finally the DOI of the slides again. And I'm hoping for some questions.
I guess there are some questions.
Yeah, thank you for the talk. Just a question. I mean, knowledge graphs, Sparkle, RDF, for a normal researcher who is dealing with biology or chemistry, this is quite complex stuff, and he never touched this before. So, and from my experience, it's really hard to convince people, hey, look at this knowledge graph, if we can write some Sparkle and answer some cool question, they would freak out and say, oh gosh, I don't want to do that. So how do you plan to solve this issue and to convince the people? So do you have already good tools? And now I see.
Well, I have an answer to this that addresses this. The issue is known to us. It's not new. And we certainly don't want to force every biologist into writing Sparkle queries or even looking at Sparkle queries. We want to make them aware that these things like knowledge graphs exist. And actually for biology's graphs are not a new thing. They are used to food webs, they're used to phylogenetic trees and things like that. And so if you explain a knowledge graph as being similar to those things they already know, they have no trouble with that. A chemist, the same thing. A molecule is essentially a knowledge graph as well, and so on. And so you have to look at, or in social science, a social network comes out of the social sciences. So you can basically translates the concept of a knowledge graph into each discipline, and then you have a much easier conversation. Still, they don't want to queue up to write Sparkle queries, and which is why I'm showing this tool here, which gives you kind of lists of queries that are pre-composed. So you think about, so this is a topic query on papers that are indexed in Wikidata. And then you can think about what are the kinds of things you would want to know about a certain topic. So for instance, the most recently published works on a topic, or publications per year, or the authors that are dominant, or the topics that co-occur with this topic, this kind of thing. And here we have this. And for each of these queries, if you want, you can go and look at the Sparkle, if you want. But you don't need to. You get the results by default without knowing Sparkle, and we are thinking in those directions, that we make the data experienceable by tooling. Doesn't have to be this tool, and then the domain people, they can work with those tools, they can provide feedback. All of this is of course open source, and so they can also talk to developers and say, well, it's principally, it's nice that it does this thing, but I actually need that thing, and so on. It's an open community. And so I think it helps promote the idea of knowledge graphs. It helps adoption in fields where it is a new thing. And maybe this can also stimulate the development of knowledge graphs in general.
Then I have a follow-up question, if this is allowed. Okay, good. Okay, so now we have solved the question of how we can use, ask the knowledge graph. So what if the researcher wants to publish stuff in the knowledge graph, and he has a large database generated with, or even Excel files, large Excel files, and he never used an RI or something like that. And we want to do fair data and to incorporate interoperability in your knowledge graph, you would have to match it. And this is not a trivial task. So how do you support the researchers on that?
That would be a case for those incubator things that I mentioned. So we already have, in the current initialization phase, we have consultancy things. We have an hour once a month where you can come with your ideas. Hey, I have this large data set. I was told it's useful to convert it into a knowledge graph. How do I do this? This kind of question you can ask there. Then we don't provide you with solutions, but we sketch out the steps that are necessary to identify whether it's actually useful to convert this thing into a knowledge graph, what would be use cases, and then if you identified, yes, it is useful, then what would be the steps to actually make this possible? And then to actually implement that, we would need to do something like this prototype incubator thing, because then we would have some resources that are actually specific to that particular task. And in any of that, we would love to work together with people who do this on a daily basis.
Thank you.
As long as they prepare the next presentation.
Be quick.
Be quick, yeah.
Yeah, first of all, I'm thankful for your presentation. Actually, I use knowledge graph for theory of constraint, and I find it really amazing for the engineering team, marketing team, finance team, because it will simplify the concept. Just to give you a positive vibe, they're doing an amazing job, and I feel that it's the future, not just for the industry, for research, and for the kids too, to understand fast, and have more motivation, especially the new generation. It's boring to see many text. They like it more dynamic. My question for you is for the next step to improve the knowledge graph about how to make a library of bigger library and more, practical for practical for the future. Thank you.
Well, it's hard to give a good answer to this in very limited time, but I can say, for instance, in the tool that I just showed, we have an improve data button, which doesn't improve the data immediately, but it gives you options on how you can improve that particular kind of data. It thinks about the data at hand, like this profile about this particular type of virus. What kinds of things are we already knowing that they're incomplete in this graph, or that there are inconsistencies in the graph? We can basically have maintenance queries that show us this. And then the user can be directed to act on those on the results of those maintenance queries, and then decide, hey, I want to really disambiguate these two proteins now, or something like this. And for that particular tool, this works because it's based on Wikidata that anyone can edit, but in principle, the NFDI knowledge graphs that we're working with, then they're a bit more restricted. You would then have to talk to somebody who actually can edit this, but you can always open a ticket somewhere. Hey, I found that these two things should be disambiguated. Please help me do it, or something like this.
Thank you.
Hello?
Okay. We are actually already over time, but last speaker is Klaus Stadler. He's a Sparkle expert in many ways, and today he will show us SparkQL views over GraphQL views over Sparkle.
Yeah, thanks for still being here, despite the overtime. Yeah, I'm Klaus Stadler from Institute for Applied Informatics. And yeah, maybe it's a good follow-up to the prior presentation with how to make querying of knowledge graphs easier. So yeah, that's a quick overview. So basically it's about GraphQL, so I will show in a moment. So so Sparkle is a standard query language for RDF, as everyone knows, and there's 4 query forms, and we don't get out any hierarchical data of any of them. So you get tabular data, RDF, or a Boolean, but often we want to have JSON to integrate with workflows. And one common example is simply, hey, how do I render this RDF data in a web page? And our approach is there's many approaches, and we try to go with the GraphQL approach. I suppose everyone knows Sparkle. I don't know who doesn't know GraphQL. Or who does know GraphQL? Okay, many. All right. Okay, there's lots of related work for GraphQL over Sparkle. So I think the 2 selling points of our approach is that we do the mapping directly in the GraphQL language. and that you can express the mappings on the query level and on the schema level, so you can do ad hoc queries with a mapping. But just for GraphQL in a nutshell, so it is from Facebook and has been basically standardized. It has a query and a manipulation part, and in our work we focus on this on the query part, and this comprises, for our purposes, the queries and the schema. Right, and when you're not familiar with GraphQL, then essentially it's a document format because there is very little semantics, so many things are up to the implementer. So let's start with a simple GraphQL query example. So that's a typical query. For instance, you say, I want to have movies and I want to have these 3 properties, and that's your query, and then someone has implemented how to answer this query. So basically someone used a GraphQL server and defined how these fields are to be evaluated. The language, so the fields, the things that you see here now, these are fields, they're called fields. And this is like a typical response you would get. So that's like the Die Hard movie on Wikidata. And and you basically need to implement the resolver. But what we can use from GraphQL is, so there's like features are called directives, like it's basically annotation, so you can add something, it's like you know it from Java or other languages. And you can use arguments on the fields, and there's also inline fragments, so this is like conditionally selecting properties based on some matching condition. Usually it's like if it's a type, if the type matches. And so, the main issue which we had to think about is how do we map GraphQL fields which didn't have many variables to Sparkle patterns. And basically, this is how we do it. We have an annotation called pattern of, and there is a graph pattern in there. And then we say which is the source, or which is the list of source variables and which is the list of target variables. In the simplest case, it's just a single variable. So you're connecting like an S to an O, that's it. But it could also be multiple variables. I will show us like an example later. And then we can actually write the query like this. So we start with movie. That's some, like, let's say Wikidata movie. Well, it doesn't connect on the starting, on the green arrow to something, but it exposes an S. And then we say the title, and then basically we even so we use the same variables here. What actually happens is that purple connects to green, and that's it. And that's how we construct the query. And then so we can combine this, and like for each field we get the graph pattern, and all we have to do is basically generate the Sparkle query from that. There's 2 implementations of our engines. I will also show the link in the end again. For the implementation, so we had some design goals. So because there's different approaches how you can evaluate this GraphQL, we wanted to have a Sparkle-based rewrite. So that means we want to be able to send the rewritten GraphQL query to a Sparkle endpoint and process it on the client side. So we didn't want to have a new server requirement for a new server API for that. Then for performance reason, we wanted to rewrite one GraphQL query to one Sparkle query, so to avoid multiple requests and all this communication overhead. We wanted to have support the directives on the query level and the schema level, so that you can ad hoc modify your query with additional mappings. And the implementation is also fully streaming. So where do we start this demo first? So basically this is a simple web page which we generated over the Wikidata, over the GraphQL query which I just showed, basically. So it's just, I took the JSON, so basically, So this is the full mapping now for like this real world demo web page. So we have like the movies, there is some Wikidata IDs in there, and then we just say, okay, which fields do we actually want to show? And it turns out that some things are not very easy to map. So it's like not we map a field to URI, but for instance, the minimum advised viewing age, it depends on the rating schemes, because each country or so, there's like different bodies that rate movies. So basically, maybe you want to either personalize it to your country, to a locale, or maybe you want to pick the minimum among all the rating schemes. For the genres, it turned out that sometimes you have duplicates in the labels because there's different Wikidata identifiers for the genres which then have the same label. So you actually need to fix, like in Sparkle, quite a lot of things to get really the result which you want. But when you do that, then basically you get this Sparkle query from it. So it's So this is what it's rewritten into. So basically for each field you have like a block. So each field you get a block, and then you have a union, a lateral join. I think it's not relevant what it does, but basically it's like a for each. So for each result of like the parent field, make a union of all the values of the child fields. That's what's happened. Yeah. Where's the demo link? So basically you can click here. Opening Chrome. Hello? No. Then here's the Wikidata movie browser demo, if I can open it. So and here we see the thing here. And so something like this. Oh no, what did you click? I'm too stupid from Mac, sorry. Yeah, I died hard, indeed. Command-Shift-D, what does that do? T. Command-Shift-T. Okay, now I'm here. Okay, anyway, so basically what, oh my God. Yeah, I don't know. I really suck with Mac with this one button thing. But anyway, so basically here, when you click on send, then you get like this JSON document out. And the web page was actually generated by just taking like two of these JSON responses and then saying ChatGPT generate a web page over it, that's it. So basically the hard part was doing the query thing here. So anyway, why can't I just switch to that with tab? Nothing happens. Yeah. That was the wrong one. Okay, so so how do we go from RDF to GraphQL if we don't want to write all this manual mapping? Well, then for this purpose we have created a schema generator. So the process is basically you take the RDF data. If it's large, then you actually want to run a summarizer over it so that you like have a representative subset. That's something you can either use a tool for it, or you just give a few Sparkle queries, like select 10 instances and all their data for each class, something like that. Because like if you have millions of instances for the same class and it all comes from the database, then I mean you just say, okay, I need 10 instances, that's it. And then the schema generator, it basically analyzes which sets of classes are linked to which other sets of classes by which properties, and this basically generates a GraphQL schema which is annotated with the RDF properties, and then you get the GraphQL endpoint when you start the server. So here is a quick other demo of that. I hope I can show that now. So here we have this Open Data Pod Leipzig demo. So basically what we did is the implementation is available as a Jenna Fuseki plugin. Oh yeah, now oh my God. Yes, I actually have a query prepared. Sorry. Oh my God. Okay, actually I just need the curly braces. Where are they on this keyboard? There is no curly brace here.
Oh, it's, I think it's...
Okay, thanks. Okay, basically, the good thing is control, what was it? Option, here, okay. So the good thing is that now you get basically type ahead. So, was it command or control? Oh my God. So yeah, let's say, no, I didn't want this, that's really I wanted to get the catalog. Okay, like there's a catalog of Datapod Leipzig, and then there is data sets in there, and then we want to have, for instance, have the title, and let's see, like typically DCAT is you have like a distribution, no, not like this. Yeah, I'm failing on the singular distribution, and then under distribution you have like a download URL, or you have like an access URL. And do I find the add symbol on this keyboard? No, it's also not printed anywhere.
Command L.
There it is, okay. It's not command, right? It's option.
It's muscle memory.
Oh my god. I never should, okay, I should, for future, I should always refuse using a Mac because I'm not familiar with it. Okay, it's really option. So skip this value if it's not null, and skip this. Yeah. Okay, but anyway, done. Maybe it's not everything, just maybe like 10 or so. It's the typical limit. Okay, this I can type. Okay, then done. Let's see if this works. Hello? Yeah. Okay, almost. I want to have pretty printing. Oh my god. Yeah, it's horrible. So pretty, and show me the sparkle characteristics. Okay. No. Okay, but anyway, now you get this JSON response out. So we have the catalog, there's data sets in there, they have titles, they have access URLs, download URLs, and so on. And here we have the generated Sparkle query. And we can actually click on the Sparkle thing, and then we go to Yasui, and then we have it also here. Hooray! So I'm nearly finished. Sorry for having to bear with me for a few more moments. This one was it? No. Was it this one? Preview. This one. Yeah. Okay. Yeah. So there are some limitations. Basically the order in Sparkle, just like in SQL, it's not defined. So you say, give me A and B, and you get back B and A because, well, the order is not defined. So it doesn't matter whether it's values or unions. Also, when you have subselected order by, that's not retained. And the current GraphQL engine, it relies on these features. It can work around if it's absent, but then it gets very expensive. You can also use mappings with multiple variables as said. So for instance, there's a use case where you have observations are blank, now they don't have an ID, but you have a composite key, for instance, composed of country and city, and then you want to connect variables to it. So for instance, here you have like some catalog with city and country names, and then you have another data set with the observation with the temperatures for that, for instance. You can also, like this is an example where you have the query. It's very simple. Just give me for each class which data sets contain this class. So this is like inverted void description. Oh yeah. So in the JSON response, you see there's like 27 data sets and you have the array behind it. And all the Sparkle stuff, it's abstracted in the GraphQL schema. So the schema, you see type, class, or data sets. The type, it has like these properties, data set count, and data sets. This is queried, and the one who queries it doesn't have to know anything about it. He gets type ahead, gets a response. Such someone has to set up the schema. And yeah, basically you can use it like, yeah, okay. Yeah, just the last thing, the last slide. So basically, you can also use in a federated scenario. For instance, you start one Sparkle endpoint with the movies data set, and then you start another on another server a GraphQL endpoint with some schema which you want, and then basically on the original endpoint you don't have GraphQL enabled, and on the federated one you have like GraphQL which goes to the original endpoint. Okay, that's basically it. Thank you very much.
As I said, whenever you have a Sparkle query, ask Klaus. I don't know if we have time or if we want to spend time for questions or if we want to take this to the coffee break.
If no one has a question?
Okay, then there is no coffee break, even worse.
So then we just start being sad.
Oh. Use case of your stuff sounds really cool. Is there some project you're using already?
Well, we used it for like, yeah. I mean, there's different use cases, right? So one is like just making a quick web page over. Hey, we have this knowledge graph. Can we make a quick web page?
This is made mostly demo, so the movie browser was one demo which is easy to grasp. We also tried like exporting, so there's another demo which I didn't show, which is like exporting RDF data as GeoJSON, because like, hey, how do we get a GeoJSON object out of it?
Which project is?
So the funded project in which I'm working.
Whatever, it's just...
Yeah, that would be Mobitex. So there the use case is you want to export RDF data as JSON into an open search because the partner doesn't want to use RDF.
Oh, now people know that is useful. See?
But anyway, you know, so basically with the system, we wrote a mapping and then you get the JSON out in a way how you want to index it. And
congratulations, Klaus.
So, at eccenca, we are usually working with name graphs to separate different life cycles of the data. How do you integrate name graphs with your GraphQL approach?
So the pattern, so in the pattern, so there's two options. One is in the pattern you can provide a graph keyword, then it matches like the relation across all the graphs. Or you can provide as an add graph annotation when you want to name a specific one, then you can basically put the pattern into this graph afterwards, the post-processing basically. Thank you.
Okay. Yeah, thank you. Thank you all for participating, and wish you a nice evening. I think that was the last session now. Yeah. Sebi wants to make an announcement.
Yeah, thank you, Magnus, for managing this session. So there is we have a small closing ceremony because I hope you remember that you all had some dots on your badges, and yeah, whoever has still a dot on his badge was not here on the opening session, obviously, because I told you this 3 times. So actually I have lost. Kannst ruhig mitkommen. So we counted the dots on the different. The first thing I want to say, I want to repeat my invitation to the Semantic Beer Garden, but now we are doing the winner awards. So we had 26 student posters, and we counted all the dots for the best design poster awards. Overall, we counted 56 dots. So 56 people looked over the student poster and decided which was the best looking poster. Thank you for that. And the winner of the best design poster award is Schwangerschaftsabbrüche in Deutschland, reproduktive Selbstbestimmung mit Hindernissen, ? From Margarita Lamas and Lucia. And these are the professor of the students. Yeah, we want to have a photo together. Nervous? No, you can. Okay, now we are going to the best semantic web poster. Here we counted overall 65 dots on all the poster, and the winner is Schwangerschaftsabbrüche in Deutschland, reproduktive Selbstbestimmung mit Hindernissen. Okay. Ja, Entschuldigung.
Mit beiden, oder?
Ah, okay. Okay.
Super. Thank you very much.
Okay, and I leave this here for everyone who wants to attend the beer garden. It's not far away, yeah. 550 meters. You're stepping out of the Rathaus, going to the right, and then you have to go 500 meters, and then you will hear the crowd, and then you are right. Okay, thank you very much for this year's LSWT.